9. Ignition sequence.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
1, 0, and lift off.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
The first spacecraft in the next generation of space communications is ready to take its place in NASA's Tracking and Data Relay Satellite System, or TDRS. The nearly 4,000-pound TDRS-K satellite will join several predecessors that provide communications between Earth and the International Space Station, the Hubble Space Telescope, and many satellites. A powerful two-stage Atlas V rocket built by United Launch Alliance will deliver TDRS-K into geosynchronous orbit more than 22,000 miles above Earth's surface. The rocket's Centaur upper stage arrived at Florida's Port Canaveral in October 2012 aboard ULA's Delta Mariner barge. From there, it was transported a few miles north to the Atlas Spaceflight Operations Center at Cape Canaveral Air Force Station. Less than 1 month later, a massive Ukrainian Antonov 124 aircraft delivered the rocket's first stage, which then joined the upper stage in the Operations Center. In December, the TDRS-K satellite arrived at NASA's Kennedy Space Center inside an Air Force C-17 aircraft. The spacecraft was taken to the Astrotech payload processing facility in nearby Titusville, where it was unpacked to start its final pre-launch testing and preparations. As 2013 began, the first stage of the Atlas V rocket was raised to vertical in the Vehicle Integration Facility near Cape Canaveral Air Force Station's Space Launch Complex 41. Shortly after, the Centaur upper stage was lifted into position and attached to the first stage. The TDRS-K satellite was encapsulated in its protective payload fairing on January 16th. Long before sunrise on January 20th, the payload departed Astrotech for the ride to Space Launch Complex 41, where it was secured to the waiting Atlas V. Now, launch is close at hand, and soon TDRS-K will begin its mission, ensuring the critical lifeline of space-to-ground communication support will be available for years to come.
Good morning and welcome to the NASA Social for the TDRS-K launch. Today we're going to have a variety of speakers present here and really share with you a little bit about this mission. They're also going to share a little bit about what's going on here at NASA's Kennedy Space Center. This is our third NASA Social event for 2013, and here we are at the end of January. The year ahead of us has a lot of different opportunities for our social media followers who are following along online at home on NASA TV, and those of you in the room here to really be involved with everything that we have. If you follow us on @NASA, if you follow us on the NASA Facebook page, follow us on our Google Plus page, you can find out about all these wonderful opportunities and participate in one of these on your own. So without further ado, to welcome you here to Kennedy Space Center today, we're going to have Ms. Nancy Bray from the social media team here at NASA Kennedy.
Good morning. How's everyone doing today? Good, good. Glad you're all here. As Jason said, I'm Nancy Bray. I do the social media here for Kennedy Space Center. And on behalf of myself, our Center Director, Robert Cabana, Public Affairs Director, Lisa Malone, I want to welcome all of you to Kennedy Space Center. We're really glad you're here. We have a great program lined up for you for the next couple days, and we're really looking forward to spending this time with you. We hope you have a wonderful time here, learning how we launch rockets and all that Kennedy Space Center has to offer. Thanks.
So as I said, this was our third NASA Social event of 2013. So far we've had pushing 50 and a little above NASA Social events, and we've brought in literally thousands of people from across the country and around the world. We're really glad that you guys have taken the time to come and be here today, and we're really appreciative of the fact that you guys get to share in our experiences and that we're able to share with you all everything that we have going on. if you guys are routine followers of NASA's social media, you can find out exactly what we have with our people, our missions, our programs, and our projects, from all of our overarching stuff on the @NASA account all the way down to many of our over 450 social media accounts that are out there for different missions, programs, projects, and people. So if you want to latch onto a little bit of that passion and everything, find a new account, start following today, and really, really, really get involved with the community that's out there. So without further ado, I'd like to start by welcoming our first speaker, Mr. Badri Yunus. He's the Deputy Associate Administrator for the NASA SCAN office, which is the Space Communications and Networking Group at NASA headquarters. So he's here to tell you a little bit about the overall network and why the TDRS K mission fits into that. So without further ado.
Thank you, Jason. Well, good morning, everyone. Hopefully, if all goes well, tomorrow we'll have a successful launch of our TDRS K spacecraft. The TDRS K spacecraft is a critical element of the space network. The space network is one of 3 networks that's managed by the SCAN program office. And I'm the Deputy Associate Administrator with responsibility for overseeing all of these activities, putting out the policies and managing all activities related to space communication and navigation, in addition to spectrum management, as well as data standards. This is my second opportunity before the social media. The first time I had it recently, actually at Goldstone. And I discovered that you guys are the best friends that someone can have. So I don't know who attended the event at Goldstone. Hopefully, we have, repeaters that people can shuttle around the country covering these events. But I discovered your love for space and your belief in NASA. We share that belief. We share in our vision of the future, and hopefully we'll never disappoint you. I have a series of charts that I would like to go over my program, and to educate you somehow on what we do and where we are going. This is the program office. Our responsibility is to definitely managing all activities related to space comm and nav, and we also enable related technology. With all of these assets that have evolved over time, one independent from the other, I have a responsibility now to integrate all activities into a single cohesive network of networks. In the process, we eliminate redundancy, and we save some money for the taxpayers, but also we prepare the stage for the future explorers, that the future explorers will not be bounded by the boundaries of each network. They will crisscross these boundaries, and they will need the kind of seamless communication and capabilities that we can provide for them. So we are paving the ground for that to happen. We continue to expand the capabilities, and we introduce technology in support of both human and robotic missions. We manage spectrum, as I said. We do the data standards as well as navigation standards. We are the ones that put out the policy related to positioning, navigation, and timing, the PNT. So we are involved with GPS, and we collaborate with other government agencies. And my office is responsible for negotiating with foreign entities on behalf of NASA for anything that relates to these areas of responsibilities. Next chart. So what do we do? We are the AT&T, the Verizon. We are all of these companies that provide telecommunications capabilities to get the data, the information from point A to point B. We don't act on the data. We just, we are the carrier of the message. We try to enable the users to get all of their messages and all of their data when they need it, where they need it, across the globe. And also, we go well beyond the globe, throughout the solar system, supporting the planetary missions all the way to the edge of the solar system. We have a spacecraft that has crisscrossed these boundaries. You all heard about VJ, Voyager. It's getting there. We are debating whether we've gone beyond the edge of the solar system or not, but we are at that edge. Next chart. We have an extensive infrastructure distributed worldwide, from the North Pole all the way down to the South Pole. And we have these networks color-coded. You can see the green represent the near-Earth network. It caters to anything around Earth, very in proximity, of Earth, all the way to 2 million kilometers. This is the boundary of near-Earth and deep space. We also have the Deep Space Network, 3 stations distributed worldwide, separated by 120 degrees one from the other, to provide 24/7 support to all of our deep space missions. And they are colored in burgundy. Burgundy, I like wine, so I don't know whether this is burgundy or not. And we have the blue color, which represent the space networks. We have the 2 main stations down in New Mexico. They are supposed to provide redundancy, backup, and continuity of operation, one with respect to the other. But later on, I will touch on the reason why we also have another remote station operated in Guam as part of the space network. Next chart. So nothing goes on board the space station without going through us. Once we launch the spacecraft, any mission, it's in our hand, its future, its well-being. Anything pertaining to the mission of that particular vehicle, requires our attention and requires the kind of support or enabling support that will allow it to carry on with its mission. Prior to the station, we provided also support to the shuttles, the orbiter. In addition to that, people don't know that we support all of the launches that take place here in the United States. Any mission that launches from here, it has our assets pointing to it, supporting it all the way to its destination. And so we are preparing the stage for the future, as I said, to make sure that the future human exploration will be carried forward as contemplated, as planned, and without having to worry about communications. If I go from low Earth orbit to a higher orbit all the way to deep space, do I need so many sets of equipment? That's a lot of burden. That's a lot of cost. It takes a lot of space on the vehicle. My challenge is to have it seamless to them, trying to integrate all of these capabilities into a single box so that they don't have to worry about comm and making space for other scientific and other activities on board the vehicle. Next chart. What are the missions we support? We support everything, from astrophysics to heliophysics to space exploration to whatever, space research, anything you can think of has to go through our assets. For example, looking at the origin of the universe, the Hubble telescope, without our capabilities, in particular the space network that provides real-time support, continuous data flow between the mission and the mission operations center. Without it, it couldn't have been possible. All of these beautiful images of the stars and the universes and the galaxies that are born and those who are dying, that goes through us. Same thing when we talk about planetary mission. The lunar orbiter, as well as the Mars orbiter, as well as the recent landing of the Mars Space Laboratory, or Surface Laboratory, science. All of the pictures have been carried to you by us. So we do a lot of activities around Earth. Our attention is not just to deep space. Around Earth, we do a lot of Earth observation, from climate to studying the atmosphere, stratosphere, all of the layers, studying pollution, studying the state of health of the oceans and whatever. All of this done through the NASA mission, and sometime in collaboration with other space agencies. And I see people hurrying me, so you have to bear with me. Next chart. This is our mission. NASA told us, you'll enable the users, you'll build super duper set of capabilities, We want you to increase the data rate. We want you to provide for support on Mars, on the moon, everywhere, while meeting your present commitment to the customer. This Volkswagen that you have, we want you to transform it to the Lamborghini of the future without losing a single bit of data and without new money. Next chart. So this is our vision. We cannot afford it now, but we can build the kind of infrastructure, the architecture that's scalable. We build what we can. We do the best with what we can. We strive for efficiency to build the kind of technologies that can evolve. You know, it does not like later on we have to stovepipe. You know, we have something that's fully integrated that will carry us into the future very solidly. Next chart. I talked about the 3 networks. They all have different characteristics. They are managed and operated by different performance centers. The Deep Space Network is operated and managed by JPL, Jet Propulsion Laboratory. It focuses on primarily deep space. That's why they have the huge antennas, 70 meter and 34. Why? Because they catered and they focus on faint signals. You are talking about something of energy that's not detectable without the super duper cooled kind of electronics, and as well as the huge antennas. You need big ears to hear someone talking from a distance, you know. Now, the Near Earth Network, what I talked about, successful model, managed and operated by Goddard Space Flight Center, caters primarily to Earth's observation satellite. It's a model of where NASA went to the commercial sector, at least for 50% of our business, where we can find providers in the commercial sector to provide services. We go there. We don't build them, we like it. We build them because they are not out there. Our market is unique, and we only build what the market does not provide. We have primarily polar orbiting satellite going around Earth to get the repeated pictures of the globe, you know, because you need the repetition to be able to study the trend over time. So they dump their data at the North Pole and at the South Pole. We have facilities over there. You know, I like it because I have to travel and visit these places. So I do a lot of frequent, one of the frequent flyers, you know, that United can be proud of. We also have the space network. Now, in time when you can't afford long delay in transmission, you need near real-time support. Like 2 humans are talking on the phone. Hello? You cannot wait forever to get the message. You really want this near real-time support. So that's where and the space network by itself is the newest of all networks. The others date back 40, 50 years. And prior to the space network, we relied on a bunch of worldwide distributed ground stations, over 20 on the ground. We had 5 ships, 5 aircraft. We can get to it shortly. Next. Now, so this is the DSN that I talked about. And we have one in Madrid, Spain, Canberra, Australia. Actually, Tinbimbilla, near Canberra, the capital of Australia, the federal capital. And we have the biggest one is in Goldstone, California. Next. This is the kind of images recently brought to you by Scan. You know, we had to time the landing such that we had the MRO right on top of it to take the picture of the spacecraft that deploys its parachute and lands on Mars. It's not easy, you know, to do the navigation and all of this preparation. It's like having, if you play golf, you know, kick the ball from New York and having to make birdie where? In Bimbilla, Australia. It's very hard. A lot of math and science go into it. Next. This is the Near Earth Network, as I talked about, distributed worldwide, primarily North and South Pole. We also have a location here in Wallops, at Wallops. And we have also, sometimes we rely on the Air Force for support through some of their ground station. Next. The space network. Until recently, until 2009, we operated 9 of them. 1 through 10. TDRS 1 through 10. TDRS 2, we lost it on this Challenger incident. And by the way, yesterday marked a solemn occasion, this 27th anniversary of the loss of the shuttle, along with the 7 heroes that fallen. That's in their memory, you know. their loss did not go to waste. In their memory, we built for the future. We try to endeavor to do things better and to provide for future generation. So F2 also was on the shuttle. We lost it. But the two spacecraft we retired recently because they well passed their expected life expectancy. We designed them for 7 years, on orbit a few more years. They lived for 27 years. So that's NASA, really strives for efficiency, and if it still works, we'll keep on using it. So the support that we got from TDRS-1, and if you don't realize, TDRS-1, the first spacecraft, it's in the Guinness Book of Records, for providing, communication from the North Pole to the South Pole. It was done in 1999, as well as assisted NSF and a few other organizations when they needed that support. Dr. Jerry Nielsen, she was at the Antarctica, and she had medical problems, so we assisted in that. Why that? We assisted in her treatment, as well as a few other occasions. Why did we do that? Because we could. The network is so versatile, it's so robust. Our spacecraft are geosynchronous. They are not geostationary. We allow them to be inclined. As they incline, they form a figure 8, allowing them to see the North Pole and the South Pole. So this is the benefit of the TDRS, as well as the benefit of the rest of the constellation, providing near real time to all of the NASA users. Next chart. This is how we started. The cost of operating 20 stations around the globe, some of them in countries you don't want to go to, so dangerous, But we needed the footprint. The footprint of the spacecraft was critical for us to have a station in that location. But the cost was tremendous, having to operate and to maintain, sending people constantly from the States to the station to fix them, to operate them, to maintain them, was costly, in addition to finding a qualified labor at these places to operate them and help us in operating them and maintaining them. So we came up with the concept that as you go further from Earth, your footprint starts to get larger. With 2 data relay satellites, looking down at Earth, you can see 85% of what's happening on the globe, and except for an exclusion zone, it remains blind to you. About a small segment over the Pacific here, that anything below 1,200 kilometers, you couldn't be supported. So, but it would increase the support from 15% that we had before, which was not acceptable, to 85%. And we designed architected the network to have one also additional spare satellite, just in case one of them fail, we can move it there. Now, with the success of the space network, everyone was coming to us, new requirement requiring the kind of support that space network provided. Next chart. So this is where we were before. The green area is the kind of support we provided to the human flight programs and to any other mission that got supported through these ground stations. Next. Now, with what we did with the space network and the augmentation we did, we go to 100% coverage with TDRS. Near real time, continuous data flow. That's critical for some of these missions. Next. And that's when we added, in 1998, we added a terminal in Guam. We operated remotely from the White Sands. The cost is well contained, but it provides coverage for that small segment of space where we did not have coverage. Next chart. It gives you the launch date of all of the TDRSs, marking when we retired the TDRS-1 in 2009, and that was an emotional thing for us. All of us who grew with TDRS, and saw all of the kind of things it did to support the nation, to support the, economically as well as in other areas, to see it retiring, it was an emotional experience for all of us. But nothing lives forever. That's why we need to replenish the constellation constantly. 2014 is the, 2013 with the launch of TDRS-K in here. It's when we need it, because we need to have 7 operational spacecraft, 6 of them online and 1 hot spare, to meet our requirement, our present requirements. And as some of these spacecraft retire, like TDRS-3 will be retired in a year or so. Many of the capabilities have failed. We expect 5 and 6 to follow. So we need to launch TDRS-L next year. As far as TDRS-M, we are doing the reliability study to determine when do we need to launch it. I don't expect it to be earlier than 15 or 16. The thing is that we do diligence, we do the kind of analysis and studies to make sure we are doing the right thing in a cost-efficient manner for the agency as well as for the country. Next chart. This is my summary. We are doing so much more with a lot less. This is the message I wanted to carry. But we are the vanguard of enabling capabilities and support to all of our missions. Without SCAN, there is no NASA. Thank you.
Thank you very much, Badri. We've got time for one question before we move on. I see one question here.
With this new generation of the TDRS satellites, are they actually improving on systems that we have in place, or are they kind of built just to replace the systems?
Now, the genius of NASA is we designed the kind of capability that if you are to really to implement any improvement, you don't have to go to space to do it. You do it on the ground. So we designed our satellites to be bent pipe. That means they take the data and they relay it back to Earth. All of the improvement, all of the capabilities that we have added, from demand access to expanding the bandwidth and so forth, we've done on the ground, all in close to real time.
Wonderful, then. Thank you very much, Badri.
Thank you.
Next up, from Kennedy Space Center's Launch Service Program, we have Michael Woltman. He's a vehicle systems engineer, and he's here to tell you a little bit about the vehicle and how they prepare rockets for launch.
Good morning. So thank you, Badri. Eunice, that's a very good explanation of the scan and how important TDRS is to us. I'm going to talk a little bit about that a little bit later, how we use TDRS on the launch vehicle. As he explained, it's really important for us and how we move forward in the generation and launching our rockets. But tell you about myself real quick. First of all, you introduced me as Michael. Everybody here at the center calls me Mick. The only time I'm called Michael is when my wife yells at me. I started out, I heard somebody earlier say they're from Memphis. I graduated from Tennessee Tech in Cookeville, so go Vols. Very good job. Good. I've been with the Launch Services Program since 2000. Prior to that, I actually worked for Lockheed Martin on the Atlas program, working with Atlas rockets. Somebody here said, I'm glad to hear all of you excited about space, but somebody here said this was their 8th, something like that, 8th or 9th, Tom? Today, TDRS-K will be my 60th Atlas launch. Yes. So I'm very happy. And hearing Badri talk about that, I was actually here and part of the launch team that launched TDRS-K in March 2002. So I'm very glad to see that we're getting TDRS-K, the next generation of TDRS satellites up there. And the reason for that is, as you'll see later today when you go out to the pad, you'll get to see the Atlas rocket with TDRS on it. We use the TDRS network to get all our telemetry back from the vehicle during its ascent. That's very important to us in the Launch Services Program because we have a team of engineers and a team of analysts that have been working for years on this, and it's great to watch the telemetry, evaluate the telemetry, and do our job to make sure we have a mission success and get the spacecraft into orbit for Goddard Space Flight Center and SCAN. So let me tell you a little bit about Launch Services Program here at Kennedy Space Center. What we do is, like I said, we have engineers and analysts in our group. We begin by teaming up with the projects, in this case TDRS-K from Goddard, and we help them select a launch vehicle. We basically broker a launch vehicle, get them a launch vehicle so that they can get to space and get their satellite on orbit. By doing that, I don't know if many of you know this, but that process actually can take several years to get to this day. So you'll hear a little bit later from Jeff Gramling, I think, the TDRS project manager. Tomorrow is going to be an exciting day, or today is going to be an exciting day for him when we get this thing launched, because it's been several years to get to this point, and they would love to see spacecraft separation successfully, and Badri would like to see that on orbit to support scan. So that's a little bit about where we are from that. The Atlas V vehicle, I don't know if you guys are familiar with it. Again, you're going to hear this hopefully a little bit later when you take your tour out of the pad today. But tell you a little bit about this. The vehicle we're getting ready to launch is the 35th Atlas V. It's actually the 30th here from Cape Canaveral. There's been 5 from Vandenberg. The tail number for the vehicle is AV36. And the vehicle is a 401 series. How many of you know what the 401 stands for on the Atlas? Yeah? 4 meter fairing, right? 0 is no solids, right? And the 1 is a single engine Centaur on the upper stage, correct. So that's how they designate the vehicle. So this is a 401 vehicle, 4 meter fairing, no solids, single engine Centaur. I saw Badri put up MRO and the MSL mission earlier, and those were a little bigger vehicles, different designations with some strap-ons and some things like that. So that one of the other things we do here at Launch Services Program is not only support launches here from the Kennedy Space Center or Cape Canaveral Air Force Station, but we have many launch sites. We support many different contractors. In this case, it's United Launch Alliance. Ooh, that was a slip. United Launch Alliance for the Atlas V. But we do have many launch facilities around the area. We launch from here at Cape. We have Vandenberg Air Force Station, Kodiak, Alaska, Kwajalein in the Marshall Islands. So a lot like Badri, I kind of enjoy my job too because I get to travel a little bit. My boss, when she first introduced me to my job as a senior vehicle engineer, we joke that the Launch Services Program is Latin for TDY. Yeah, okay. You guys are a tough crowd, aren't you? But other than that, I can tell you that working in the Launch Services Program, it's a passion. We are a small family of engineers and analysts that love our job. We work on these day in and day out to work with the projects to get this, and to see the launch is a culmination of excitement for us. I mean, like I said, I can't stress enough of how much I love being here in the Launch Services Program and seeing this. I heard many of you talking when you introduced yourselves about how excited you are for your first launch, or maybe your second launch, or how excited you are about space. Well, since I was 10 years old, this is what I've wanted to do, and I'm loving it. And I would encourage you to, I'd love to see the social event like this that you're getting out and tweeting and Facebooking and encouraging others to get involved in space. I mean, that is an important thing for our nation as we move forward. And just a brief moment, I'll talk a little bit. Other things that we're doing here at Kennedy Space Center is, the shuttle retirement. So we're moving forward, looking at what we can do with commercial vehicles also for human space flight, things like that. Launch Services Program is involved with that also. We have a cadre of expertise in our program that is used around this center, and we love just getting involved and working on different types of missions and vehicles and getting our hands into it. One of the things I can share with you, not only myself, but several of the people I work with, people laugh when they hear this. We are engineers. I'm an electrical engineer. I heard somebody say that earlier. I'm an electrical engineer. I have a lot of friends in my organization that are aerospace engineers, mechanical engineers, analysts. But you know what one of our favorite hobbies is to do outside of work? Anybody want to guess? We build model rockets. Yeah, we do. We build model rockets and compete with them, and it's a lot of fun. So on that, I will say thank you very much for coming today, and on behalf of the Launch Services Program and Amanda Mickiewicz, our program manager, you guys enjoy your tour today, and go Atlas, go Centaur, go TDRS K.
So we've got time for some questions about launching rockets and everything, and so if folks want to raise their hand, wait for a mic to come to you, and we'll ask a few questions here.
Hi, my name is Joey Vars. I'm from Tampa. Cool. I'm from Tampa, Florida. And my question is, if the TDRS Atlas does get delayed further tomorrow, how would this affect Landsat operations out at Vandenberg for 2 weeks from now?
Yeah, that's a good question. Landsat LDCM mission is scheduled to launch out of Vandenberg February 11th. So what we would do in our program is if TDRS-K did get delayed, let's say till a day, the team is already on standby, ready to go to do post-flight analysis, analytical analysis of the flight, even if we have a 24-hour delay, to try to get that done as fast as possible to make sure we don't have any impact on the launch out in Vandenberg. Okay, there is a time period our NASA launch manager will look at of how far we can, how many times we could slip if we had to, before we started impacting the next launch date. And then there would have to be a decision made not only by our program but by the agency along with the TDRS-K project of how we get there. So currently right now there's no impact with the 24-hour delay. We do have that built in. We do build in some time for that after each launch. But if it did slip past that time, there would definitely be a lot of discussions going on how that works, and then a very quick analysis after launch to make sure we don't impact the next vehicle.
Questions? Other questions? Don't be shy, guys. Here we go.
Yeah, don't apologize. Don't be shy. I love answering questions.
Hi. I didn't actually realize until you started talking that the numbers designating different series signified actual useful information as opposed to just numerical information. Can you talk a little bit more about that? That's actually really interesting.
Yes, the Atlas 5 is actually a how do I put this? The Atlas is an evolved vehicle. We started out with, many of you probably remember, with the first Atlas booster, 10B, that was launched way back in the 60s. That was an Atlas booster, old ICBM. The vehicle has actually evolved since then to become what we know today as an Atlas 5. We went through an Atlas 1 series, which was an Atlas with a Centaur, and then an Atlas 2, which had upgraded avionics, and an Atlas 2AS, which was then upgraded avionics with solids strapped on. And then we went to an Atlas 3, which was the integration of the RD-180 into the Atlas booster, and now we're at the Atlas 5. Throughout the whole program, the program has used a numbering system to designate the vehicle two things, the AV being Atlas 5, or previously it was AC, Atlas Centaur, and then the number, in this case it's tail number 36. A tail number is assigned to the launch vehicle for manufacturing and getting through. Now, when we moved to Atlas 5, we also adopted the numbering of the 401, the 521, and so that we could keep track of the configuration of the vehicle, being a 4-meter fairing or a 5-meter fairing. Are we flying one solid or two solids or three solids or five solids, like Pluto New Horizons was a 551, 5-meter, 5 solids, single-engine Centaur. The Atlas 5 vehicle is designed, has the capability of having a 2-engine Centaur, but we've not flown one to date. So we've only done a single, so all of our numbers have ended in 1. So that's where the numbering comes from a manufacturing configuration tracking. You're welcome.
Other questions?
Yeah, once the Atlas 5 gets human rated, how is that going to affect launch operations and your manifests out here? Because it looks like you guys are pretty booked already. Are you going to need more facilities or personnel?
That's a really good question. I can tell you that we're still assessing that from the aspect of how we in Launch Service Program would support that. But of course, Ed Mango and his group and commercial crew are still also looking at that on how a commercial vehicle, be it an Atlas 5 or anything else, gets human rated, what would need to be done either with the launch facility at Launch Complex 39 to be a multi-use launch pad, or whether we would use the contractor's pad still at 41 or 40 if it were an Atlas 5, and how that would go. Now, from an analytical engineering standpoint, we in Launch Services Program are poised to support, just like we would now for an unmanned mission, on how we would go about doing analytical work and insight and oversight of the launch vehicle. Again, we're still looking at how much more would be required, but we are prepared to support that and move forward for our future in the nation.
We've got time for one more question. Who's got a question? Here we go.
I'm going to go a little bit different route. Here, interested specifically for our youth. And message to the youth, I come from a rural area in the Midwest, and we do have some success as far as our students being very interested in STEM. And so an outreach today in regards to what do you tell our students that are young and interested in space and the opportunities they might have? What would you say to them as far as trying to get involved with that?
Yeah, that's great. Youth is a passion of mine also as a volunteer youth director with my church, but also in space. I love talking to kids at school. Here at NASA, if you're not familiar, just to pause from your question a little bit, we do have a great outreach program you should probably get a hold of for your STEM stuff to get some speakers out there and also do some demos of some rocket stuff and all that. But if I were standing in front of a bunch of youth today, what I would tell you is continue your dreams, continue moving forward what you're doing. Math and science, very important. Also your English, and I can tell you that in a minute, but I would say continue moving forward, doing what you are planning to do. If you have a dream to work in space or do anything, keep moving forward to it and keep working at it. You may run into some bumps along the way, like many of us have, but if you put your mind to it, you will get there, and I can only tell you that it is so gratifying to be able to sit in the launch complex or the launch control room and watch, like some of you will today, see the rocket leave the pad and watch the many years that you've put into this. It's just, I can't even put into words how exciting it is to see the vehicle lift off the pad and then to hear the guy on the comm say spacecraft separation, mission success. It's just, it's great. And that is the end product of doing it. So keep moving forward and doing it, and don't let anybody stop you from moving forward to your dreams.
Wonderful, then. Thank you very, very much for taking time to join us today. We're going to shift gears here a little bit and talk about some of the stuff that's happening here on the ground at Kennedy Space Center. So next up, we have Jeremy Parsons, and he's the technical manager for operations for the Ground Systems Development Group here at Kennedy Space Center.
Thank you all and good morning. As was mentioned, my name is Jeremy Parsons. I work in the Ground Systems Development and Operations program here at Kennedy Space Center. I'm a technical manager there, which means I have responsibility for a lot of the operations planning activities that are going on. And really just to kind of, we're talking a lot about the launch coming up tomorrow, but what our program's really focused on is the future. We have a lot of activities going on now, but what we're really interested in is shaping the future of exploration with regards to our launch capabilities, as well as shaping the future of Kennedy Space Center here with our vision for a multi-use spaceport. For those of you that aren't aware, with the retirement of the shuttle back in 2011, with the last flight of STS-135, we are moving towards kind of a new era of human space exploration. I'm sure a lot of you have heard about the SLS, the Space Launch System, and the Orion launch vehicle. So what we're doing here is we're laying the groundwork to be able to process and launch those assets. So the SLS right now is currently scheduled to launch in December of 2017. That's the first uncrewed test flight. And for those, again, that you don't know, the SLS right now is intending for the first two flights, it's going to use a 5-segment solid rocket booster strapped to a core stage that's made up of, really it's using a lot of heritage shuttle hardware, but it's using 4 space shuttle main engines, RS-25s. And then you're going to have a procured ICPS, or interim cryogenic propulsion stage, that will get the Orion into the proper orbit, and then obviously the Orion will go on top of that. The Orion program is moving along really quite well, and so that'll be able to launch 4 crew to numerous different deep space destinations. It actually has a test flight planned for 2014, and we're calling that Exploration Flight Test 1, and that's really what they're going to do is they're going to send it up, they're going to get the Orion going 20,000 miles per hour, and then bring it back in. So they can test the heat shield, they can test really how all the systems react in that sort of environment. And what we're doing is we're getting it ready to go launch humans in the future. And so kind of what all these assets are building to is our exploration program is working towards what we call a capability-driven framework. So what that means is we're going to build on our exploration capabilities piece by piece. So we're going to start with, we're going to have a launch vehicle. We're going to have a crewed human capability, right? So that'll take us beyond low Earth orbit, and we'll be able to go to a deep space destination. And then we're going to add further capabilities that allow us to kind of go further and further out into deep space, with the ultimate goal being to get to Mars. So for example, the SLS is going to start out as a 70-ton launch vehicle. I mean, that's still massive. We're talking a 320-foot tall vehicle. It's going to have quite a bit of capability. So we're going to start there, but that's eventually going to evolve over a number of years to a 130-ton class launch vehicle, which will be the most powerful rocket really ever built. And at that point, it'll move from 320 feet tall to 380 feet tall. So that's kind of just laying the exploration groundwork. What we're doing here at Kennedy is we're preparing all of the infrastructure and assets we need to be able to make all of that happen. The other thing that we're doing is that we're making Kennedy Space Center a multi-use spaceport. So we have a vision for what we can do out here. We have a number of unique, one-of-a-kind capabilities, infrastructure. When you look at places like the Vehicle Assembly Building, which if you drove over the bridge coming into Merritt Island, you can see it from many miles out. It's one of the tallest buildings, one of the largest buildings in the world, I guess I should say, one of the largest buildings. It's standing over 525 feet tall. It's massive on the inside. And so that's not something we can easily duplicate. So what we're going to do here is we're going to go in and we're going to take out all the old Apollo shuttle era platforms and High Bay 3, right? And then we're going to modify that and make it ready for stacking the SLS. But we're putting a little bit of a twist on that, which means that we're not just going to set it up to where it can only stack the SLS, to where you have one configuration and it can only process the SLS. What we're going to do is we're going to make it to where we have reconfigurable platforms. So the idea is we'll be able to process any number of launch vehicles through that high bay. So for example, if you come in there with an SLS, you have one platform configuration, but then say down the road, some other launch vehicle, some new launch vehicle wants to come in, they need a vertical integration capability. We'll be able to change the elevation of those platforms, change the diameters of those platforms to where we'll be able to process through any number of different launch vehicle variants in a vertical configuration. Which is really pretty exciting stuff. And the idea here is we want to be able to make our assets available to a number of different users. We want to increase the manifest out here. And we really want to drive down the cost of space exploration to where, again, any number of users can open it up. As part of that, what we have is, so I talked about the vertical integration capability at the VAB being multi-use, but then we also have launch pads. So probably one of the most recognizable assets that we have out at Kennedy Space Center is the launch pads, right? You've all seen it with shuttle launches. It's been photographed innumerable times. So what we've done here is we've taken Launch Complex 39B and we've actually really started modifying that. And what we're doing is we're making it, again, a multi-use launch pad. So one of the first things we did is we went out there and we knocked down the fixed service structure and the rotating service structure that were used in shuttle. So now you have a clean pad. We put up 3 600-foot tall lightning towers, so that'll really protect for just about any vehicle that wants to come through there. And then so we've really brought it down to a clean surface. We then went through and removed, I think it was somewhere around over 1 million miles of cable that was underneath all that area there. And it's just, I mean, again, this was Apollo to shuttle, and so now we're just bringing it out, we're refurbing it all to prepare it for the new exploration program. So now we have a clean pad surface. And so again, in the future, if another user wants to come in, put their own kind of mobile launch platform out there, they will be able to use that launch pad. And again, a launch pad is not something that can be easily duplicated, right? That's a whole lot of cost for someone to come in and use. So if they can use our asset for a time period that we're also using for SLS, boy, that's great. They get a low cost of entry and we get multiple flights out of this area. And really, that's, again, behind our vision, right? We want to make KSC affordable, we want to make it sustainable, and we want to have it to be a busy, robust spaceport. So again, at the pad, one of the other things that we've done, again, when I say it's a clean pad, what that means is that we want to push most of our SLS and Orion processing work back into the VAB, do our vertical integration there, and then we want to roll out and launch as quickly as possible. With the shuttle, you had about a 30-day pad flow. And what we're trying to do is we're trying to get that to 10 days or less. And really what we're shooting is 7 days or less for our pad processing flow. And what that means is that we have the vehicle less exposed to the environments, you have less risk, so you're trying to do all of your processing in a good controlled environment, roll out and launch as quickly as possible. So it's kind of a departure of our operations concept. What the SLS and Orion will actually launch off of is a mobile launcher. I don't know if you guys have seen pictures of it. We built it originally for the Ares 1 under Constellation. We built the structure of it, I should say. And when Constellation was canceled and we moved to doing the SLS program and the Orion programs, what we said is, well, we've invested quite a bit of money in this structure, so we engineered a way to where we can use that for the new exploration program. And so the ML, if you actually drive out through the LC Launch Complex area, it's hard to miss. It stands 355 feet tall. You can see it from miles around. And it's a neat structure. And what we did is we enlarged the flame hole on it from the Ares 1 design, and then we enclosed a certain amount of structure, and we've designed all new systems for it. But we're going to be able to use it for the SLS. So what that means is this mobile launcher, we're going to stack the SLS and Orion on top of that. We're going to take it on the crawler transporters out to the launch pad, and we're going to actually be able to launch it off there. And then we just reel it right back into the VAB, and you can refurb the entire tower. And so again, that's all part of the idea of having a clean pad where you don't have all this standing structure out there in the environments right next to the beach, and we're going to be able to kind of keep it enclosed and inside the VAB for the most part. Kind of looking a little bit broader at the Space Center, we're also doing design work on the shuttle landing facility. So there you have a one-of-a-kind landing strip. This is one of the largest runways in the world. And so we want to be able to use that for other space endeavors. And so what we're doing is we're looking at bringing in horizontal takeoff, horizontal landing type vehicles, similar to Virgin Galactic, something along those lines that could use this runway. And so we're talking a lot about what services they need and what we can provide. And actually, even at the end of the landing strip there, we've established some vertical takeoff, vertical landing type capabilities where folks are doing test flights and things along those lines. So I kind of was trying to give you a little bit of a broad perspective of what we're doing here to support the exploration program. I would say if I'm talking too fast or if you have questions, definitely I will encourage questions, and I'll finish up here shortly. What our specific job is within the operations group is really stuff that I get pretty excited about. So we've stood up an operations team that's really leveraging the experience of the engineers that worked on shuttle, that worked on LSP, and really across the board. And what we're doing is we're trying to get them involved early in the design of the SLS and the Orion vehicle. So what that means is, for example, we have a number of folks that are used to operating these systems, that have run launch countdowns. And so we're telling them, okay, what do you want out of the design of this vehicle? What do you want out of the design of those ground systems? And the idea behind that is we want to make these systems easy to use, we want to make them easy to maintain, we want to make them highly reliable, and really sustainable, right? Because that's the idea. You don't want a ton of manpower to run these systems over and over and over. You want to do it as optimal as possible. So we're doing things like, for example, we establish reliability targets, right? So we want our systems to be, over 99% reliable on the day of launch for the ground systems perspective. So what we do then is we go through each of our ground systems designs, we do detailed requirements and reliability analysis modeling, and then this is the operations team I'm talking about. And then, for example, we make recommendations. So if they have a single box that's the most likely failure, well, we say, hey, you can change that out with a more reliable part. We also do simulations analysis. So for example, if you're going to go conduct a really complex mission to Mars, you're going to want to launch a number of different missions within a relatively short time frame, and you want them to be able to mate up on orbit, and you need to have high chance of success, obviously. So what we do, for example, is we run simulations here where we figure out, okay, here's how long I think it's going to take me to process and launch a vehicle. Here's how many assets I need in order to do that. Here's the chance of success. You can incorporate modeling for weather, for any sorts of events. And as we change our designs, we can measure how are we doing relative to those targets we need in order to have a certain loss of mission risk. So that's what a lot of our team does. The other thing we do is we go through and figure out exactly how we're going to process this vehicle, and we relay that all back to the design center. And so, for example, if we need additional access doors in the vehicle, if we need access to certain heights, locations, etc. That's all stuff that we relay to them and that we work through. And the idea, again, is that by the time that vehicle gets here, we've already worked out in a 3D environment exactly how we're going to be able to process it. We have detailed knowledge of where everything needs to be, and so we can hit the ground running and get this SLS launched in December of 2017. So that was really about all I had for kind of the main talking points. What I would also say is that GSDO here locally, our ground systems organization, we're really proceeding along according to schedule, and we're doing really well. We just completed our systems requirements review, which for those of you that don't know, it's a critical milestone where we go through and we say, what are all the requirements for the program? What are all the things we need to deliver? And we have it vetted by a cross-program, cross-agency type team of folks. And so they look at your schedule, your budget, and really all of the details you've done to this point. And we passed it with flying colors, and we're proceeding on to preliminary design review, which we're going to hit early next year, about January of 2014. So again, all of our systems are really moving along well, and I guess I'll open it up for questions.
Questions, guys? Don't be shy.
Have there been a lot of requests for the horizontal landing strip recently?
So there's been a lot of interest, I would say. As far as agreements signed and things like that, there's a number of discussions ongoing, but we've talked to a number of different companies. I mean, as you know, that's an area of space that's really getting a lot of interest, right? Because they're interested in commercial space flight and getting tourists up there and things along those lines. So there's companies like Xcor, Virgin Galactic, and Maston that are all kind of spinning up looking at this. So what we've done is we've talked to them about our capabilities. A lot of them are actually looking at our engineers to some degree for experience. So I would say there's a lot of interest, but really at this point, discussions are ongoing. And I would also say that what we're doing is we're looking at designing the infrastructure that's required. So we've talked to a number of different customers, a number of different users, and what we're doing is figuring out what they need out there in order to process vehicles.
Good morning, sir. Hope my question is not political in any sense, but it was exciting to hear you talk about the different things that NASA is looking into in terms of its expansion and different ventures going forward. How much is NASA actually looking, or should I ask, is NASA looking to becoming a spaceport here at Kennedy versus an open project market where in other words, are we looking at something like the space shuttle where it's an ongoing program, or just a spaceport for different ventures to come in? I'm hoping that we're going back to some kind of programs where we have ongoing launches and ongoing capabilities and things like that.
I mean, I think the answer, in a lot of ways is yes, right? So we want to do both. So SLS and Orion is kind of what I would consider to be an anchor tenant for a lot of these assets. You need a VAB and a vertical integration capability to process the SLS and Orion. You need a launch pad. So we're already building those assets. What we're saying is that, depending on the manifest, there could be a lot of capacity that is available for other users. So for example, in order to process the Orion, we need hazardous processing capabilities. We need to be able to put in hypergol propellant. We need to be able to pressurize high pressure tanks. And so if there's another user that could come in there, say out of 1 month, 2 months out of the year and use those same capabilities, great. I mean, that's kind of a win-win scenario for everyone. So that's kind of the vision here. And so, when I talked about the vertical integration capability in the VAB, if another user could come in and we can use our reconfigurable platforms to also process that vehicle, it'll probably save NASA some money in the long run, but it'll also help the commercial industry kind of move on and move forward. So the answer is yes, it's going to be both. I think SLS and Orion will really be the anchor tenant of a lot of these capabilities, but we'd love to see it used by a number of different folks.
We've got time for one more question.
There was recently, a few months back on the news, that you were looking at the possibility of finding buyers for the shuttle landing facility and maybe one of the launch pads and properties and things around here. Is that still a possibility, or is it more like a lease option? Or you're hearing all different kinds of things in different of the media.
So I'll probably be too careful, and I'll let one of these PAO folks answer it before too long. But there are a lot of discussions ongoing. What I know KSC has done is we submitted a request for information to see kind of who wanted to use some of the assets that are available. The shuttle landing facility has a number of customers that are already ongoing, so I don't really know what the discussions are there. But I think in general, there's interest. There's definitely still some talking about lease options, but I think that one is probably a little bit above my head as far as politically what's all going on there. I know that we're supporting them in any assessments. But.
All right, wonderful. Thank you very much, Jeremy.
Cool.
So we've got a special treat next. We have Dr. Compton Tucker. He is the senior biospheric scientist at Goddard Space Flight Center, and he's worked on a variety of projects that have used data that have been downlinked via the TDRS network. And so he can talk a little bit about how it is as a user of the TDRS network to actually get stuff off of it. So here we go. Thank you.
Thanks a lot, Jason, and good morning, everyone. Now, where I fall into the scheme of things with TDRS, I'm on the absolute back end because I use data which have been collected by satellites, and some of those data are then transferred to the TDRS satellite and then down to the various ground stations which are operated by the SCAN network. So I'm at the back end, I'm in the science area, I'm an earth scientist, and I use satellite data to study climate, because you can only study climate if you study the Earth as an entity, and you need to do this through time. So you don't just make a few measurements in 1 year, but you make measurements day after day, week after week, month after month, year after year, and decade after decade, because if you want to study climate, you need to look and see how things vary over at least a minimum of 30 or 40 years to understand what's happening, how things are changing. What happens inevitably is this poses more questions, why? And so we answer some fairly straightforward questions, but then we're faced with many more questions, and this is what we are involved in scientific research. So the point I want to make is that the TDRS system is vital, and TDRS-K is a third generation in the TDRS series of satellites, and so there are substantial improvements. As time goes on with our advances in engineering, we're able to build better and better satellites, make them more reliable, and make them much more capable, and TDRS-K is the first and the third generation of TDRS satellites. Now, I'm going to be talking about science data, and I will illustrate this by talking about some data from the Hubble Space Telescope and from Landsat 5, which ceased operations last year after a run of 27 years. But also, at the moment, there are some really interesting things within NASA. People are building instruments and deploying them on the International Space Station. And the reason we're doing this is because this is an ideal platform. When you have a International Space Station, a reply mission, or supply mission, excuse me, you can take up an instrument and then have the people there bolted on. And then if you want to bring it back after 2 or 3 years, you can bring it back. And so this is an excellent platform for doing exploratory Earth and space science. Next slide, please. So this is just a schematic which I would think you may have in your handout materials showing where the TDRS satellites are. There are 2 which are operating plus several hot spares, but there are actually 5 or 6 that are operating, but the 2 principal ones are TDRS West and TDRS East, and the associated ground stations. Next slide. So this is a much better artist's view of the International Space Station, the Hubble Space Telescope, and then 3 of the TDRS satellites. But it gives you an idea of what we're looking at when we have these satellites in geostationary orbit, which means they're up just under 36,000 kilometers above the equator. And so as the Earth rotates, the satellite motion is such that the satellite is above the same point on the Earth's surface as the Earth rotates. And this is one of the advantages of being in a geostationary orbit. Now, what I'll be talking about are data from the Hubble Space Telescope and from Earth orbiting satellites at much lower elevations. And in the case of the satellites which I use, all of them are in polar orbits, which means they go around the poles as the Earth rotates. And the orbital period is about 100 minutes, and so you get data day and night, hour after hour, week after week, year after year, decade after decade. Next slide, please. So why NASA? One of the really cool things for me about working at NASA, and I worked at NASA now, God forbid, for about 35 years, is it's fun. I enjoy going to work, and I get to work with a bunch of people who are really interested in science and technology, and even if they aren't engineers or scientists, they really care about NASA, and they really enjoy the work which we do, and so it's just a lot of fun. And we're doing things which people have not done before. You don't always succeed. In fact, many times we fail, but we all know how much we have learned from our failures, and you just do it better next time and don't make the same mistake twice. Next slide. Now, one of the really cool things about working with the people in the in SCAN, the the organization which is responsible for communications and space data is that I get to stress why it's so crucially important to reserve portions of the electromagnetic spectrum for science. Now, this includes several very key frequencies which we use to study very unique features about the Earth's surface. So, for example, if we want to take temperatures of the atmosphere as the satellite is passing over, there are certain frequencies which are really, really important. In fact, they are unique. And so these are areas of the electromagnetic spectrum which are off limits to other people for other uses because of their paramount scientific value. The same thing is true if we want to study sea ice. At the South Pole around Antarctica or in the Arctic region, there are other frequencies which are crucially important to study sea ice and to do so uniquely. And then we have other instruments which are basically radars in orbit, and we use those to study sea level and how that varies over time. And the same in terms of the salinity of the oceans from a new mission called Aquarius, which is really unique because now we can look at the salinity of the ocean water and see how this varies and why. Now, on the TDRS-K satellite, there are 3 broad wavelength regions or frequency regions which are crucially important for the data transmission. And those are the S bands, the KU bands, and the KA bands. And the frequencies are here. And if you're curious, I'll be very happy to post my presentation to you, and you're welcome to use it in any way you would like. Next slide, please. So now let's talk about what is probably the most amazing instrument ever constructed by people, and that is the Hubble Space Telescope. Now, it takes me a lot of serious consideration to say that because I'm an Earth scientist, but my friends who are space scientists are fortunate enough to be able to use these data directly. Next slide. So one of the things from Hubble, which I find very cool and also amazing, is they've been able to estimate very accurately the number of galaxies in the universe. And it's only about 80 billion, or say 100 billion. So about 10 to the 11th total galaxies in the universe. Next slide, please. And then you can look in more detail with Hubble and actually begin to count stars and galaxies. And they're on the order of something like 100, 200 billion stars in each galaxy. And so next slide, and so when you just multiply this out, next slide please, you get just an incredible number of stars in our universe. Well over 100 billion trillion stars, or about 10 to the 23rd power. But this is just indicative of the amazing advancements which have been supplied to us by the Hubble Space Telescope, and we wouldn't have these data if it wasn't for the TDRS satellite system bringing the data down to Earth. Next slide. So now I'm going to change my science focus from space science to Earth science, which I work in day after day, week after week. And this slide shows some of the constellation of the Earth orbiting satellites which many of us in Earth science use. And once again, these are in polar orbits, and the reason they are in polar orbits is to get repetitive data of the Earth over time so we can study how things vary. Our ability to use data from satellites and incorporate them into numerical weather prediction has advanced tremendously over the past 20 or 30 years. And with these advances from weather satellites, we're able to get very accurate predictions of what is going to happen 3 or 4 days out, 5 or 6 days out. But these same data over time provide information about climate, because climate is simply weather over long time periods, tens of years or more. Next slide. Now, I'm going to conclude my presentation and show some things which I'm working on. And in my work, what I do primarily is study global photosynthesis using satellite data, but I also study forest carbon storage, and I also study glaciers. And I've just completed a paper on the glaciers of Turkey, and my coworkers and I are working on a much bigger study where we're looking at the glaciers in the tropics. Now when you think the tropics, well, why are there glaciers in the tropics? Well, these are very unique glaciers which exist at very high elevations, from 4,500 meters up above 6,000 meters, up above 20,000 feet. And these occur, about 99% of them occur in the New World, from Mexico all the way down to Bolivia. And so what we're doing is using satellite data to study these glaciers, and they're also unique because they expand in the summer, which is the wet season, and they contract in the dry season or the winter. So these are in the tropics, they're very high elevations, and you have about 70% of these in Peru and about 20% in Bolivia. So to do these studies, we need to use satellite data because you can't walk around the margins of all these glaciers. There are simply too many, even though we do that in selected places for verifications of what we're measuring. The next slide, please. So this is one example of some comparisons which we were able to make, and we're very fortunate because of TDRS that we have data from Landsat 5 from the mid-1980s. Without the TDRS satellites in the mid-1980s, we would not have the archive of Landsat 5 data to work with for our glacier studies or for many other studies, because Landsat 5 documented a wide variety of land conditions in the mid-1980s only because TDRS was there to receive the data and then retransmit it to the ground stations. So what we're able to do is then take data from Landsat 5 from 1986 in this case, and also 2006, and we hope within the next year we will have data from Landsat 8, which is scheduled for launch, as someone mentioned, in just a few weeks, in 2 or 3 weeks. And it's with data like this that we have quantitative information, what is happening in terms of glaciers. Now you say, well, why are we so interested in glaciers? Next slide, please. Probably nature's best thermometer is ice. And when it gets warm, ice melts. And so this is a picture of one of my colleagues. I actually took this picture because this colleague is a much better ice scrambler than I am. We're up about 17 or 18,000 feet in the Andes. And what we do is we go to selected places where we have road access, and we walk around with GPSs on the margins of glaciers, because we need this information to compare about what we see in our satellite data. Because if you don't have an on-the-site verification of things, you could be radically wrong and very, very embarrassed. And so it's important to do selected field work, but you don't want to risk your life or limb if you're not certified and like to climb, which I don't. Anyway, so next slide. Now here's a picture of some places where I've been to where we simply walk around the margins of glaciers with a handheld GPS and then take selected GPS measurements, and then we will then compare those boundaries to what we observe in the satellite data. And if they don't agree, then we go back and do it again next year. But they do agree, and this is the basis for giving us a very high quantitative confidence in what we do. Next slide. So from our New World Tropical Glacier Study, and this is almost all the glaciers in the tropics and on our planet, what we've found is in the mid-1980s we had about 2,500 square kilometers of glacier, and then by the mid-2000s about a third of that had been lost. And this histogram shows you in blue where we had glacial ice in the tropics, which is then binned or stratified by elevation, and then in red where we had glacial ice for the same areas from 2004 to 2008. And what you'll notice is most of the loss, or the difference in these bars, is at lower elevations. So it's data like this which we use then to get information about glaciers and see why they're varying. Now at the same time, glaciers can vary because it is snowing less, or it's getting warmer. So you also have to analyze precipitation data, you have to analyze cloud cover data, and you have to especially be very careful in what you're doing. And so we have done that, and unequivocally the culprit for the tropical glacier recession is warmer temperatures, especially warmer temperatures in the winter and at night versus in the day. Next slide. So in conclusion, TDRS is not only vital today, but it'll be vital tomorrow and in the future, and it's been extremely important for the collection of science data from space science and from earth science, because it's only when you have data to base things on that you can tell what's happening, and this moves things out of the realm of belief into the realm of observation. And we all know observation is great, and as they say, there's nothing like an eyewitness to spoil a good story. TDRS enables that to happen by its retransmission of data from satellites in my case, and it's a pleasure for me to be on the back end actually using data from Earth science satellites as a scientist, but I have to acknowledge the tremendous amount of work done by the engineers who build the instruments, who build the rockets, who launch them, who also provide the data system to get the data down. So one of the great things about NASA, once again, is we get to work as a team, and you get to work with a lot of people like all of you, I think, who are really interested in space, and it's just fun doing it, and it's a pleasure, and thank you for your attention.
So we've got time for a few questions, so we'll start over here.
Okay, so on your slide previous to the last slide, you showed a graphic of declining glaciation, right? At
Yes.
higher elevations, but at lower elevations. But at higher elevations, it seemed to be stay pretty level. So why is that?
Well, that's because as you go up in elevation, things get colder. The air temperature gets colder. And that's just a function that what is happening is the snow line or the ice line is moving up in elevation as it warms. And so you would expect this to not be as pronounced at higher elevations because of this temperature relationship with height. And so that is to be expected.
Does that mean then that carbon doesn't have as much influence as we once thought it did?
No, not at all. In fact, what it says is that you have this progressive warming of the lower atmosphere and the upper atmosphere too, but it's only in the lower atmosphere when that warming gets above the freezing point for more of the year, and so more of the ice melts. Now, it's also possible that it can ablate, and that is have a direct conversion from the solid state into the vapor state. But that takes about 8 times more energy than just melting water.
Okay.
So I hope I have answered your question and not confused you.
No, I would have presumed because of the sun's more direct contact with the mountaintops and higher elevations that it would
Well,
have.
but you also have to think about nighttime temperatures.
Right.
And so what happens is even though you're at very high elevation, say if you're above 20,000 feet or 6,000 meters, it's going to be really, really cold, and the air temperature there is always going to be below freezing. That will not be true if you're down around 4,500 or 5,000 meters. And 5,000 meters is 17,500 feet, so you're still pretty damn high.
Terrific. Thank you.
So if you want to get warmer, and if you're working at high elevations, you always go down to lower elevations. There's the added benefit there's more oxygen. One of the bad things about working in the Andes or in places where you have to work at very high elevations, it's not so bad during the day when you're active. And what we do is we drink decaffeinated Coca-Cola with aspirin, which is called cola aspirina. And that seems to get rid of the headaches of lack of oxygen. But at night when you sleep and your breathing slows down and you breathe more slowly and less deeply, you get less oxygen and you'll wake up after an hour or two with a splitting headache, have to get up, walk around, and then drink some of the decaffeinated Coca-Cola, take some aspirin, and then go back to sleep again for a few more hours. But this is really fun, and I'm not complaining that I really enjoy doing it, but some people wonder, well, what is it like to work at high elevations? Some people's systems, I can't take it, but I can usually adjust mine after a few days.
Okay.
Doctor, maybe this question is maybe more for Badri than yourself, but I want to talk to you about data relay recovery and how it's worked here. Obviously, bandwidth and time is a big concern. Standard procedural methods is the one-to-one linear fashion. And I'm asking you today, are there other methodologies that we're using here at NASA to relay heavy amounts of data? Because you're obviously using massive amounts of data that's coming back at you. Is it all one-on-one linear?
Well, I don't know the answer. I could guess at it, but it would be better, I think, if one of my network colleagues from NASA headquarters who could answer that in a very precise way. I can only assume how it's done, but that's guessing. So perhaps either Vic Sterling or Badri could answer that question.
It's okay.
It was a good question, but I don't know the answer, but I'm sure someone here can answer it.
Thank you.
And so Badri...
Can you repeat the question and I will attempt to answer it because this should
Okay, here's this microphone if you want to use it.
all one-to-one computation, or are you using different types of like anagram data where you're sending a line, you can unlock the data, and give you the answer, or is it all one-to-one computation?
Yeah, for the most part, depending on the techniques that you use, we do not act much on the data. The only thing that we do with the data is to check the state of health. That means we have a link, and the link is viable and it's healthy to allow, for the data to be transmitted. Now there are a lot of techniques we use. How do we package? How do we frame? How do we transport? But it's not. We don't do it in a very unique way. We very often cater to the needs of the customer. And we have a variety of customers. On a daily basis, we support 100 of them.
Well, for example, in our space lab, based on the bandwidth and the time that we have to send out that data, I'm just curious if it is all one-to-one. Are you packaging it up in a special zip file per se and sending it in the lock?
The space network does not package, just it zips it as it gets it, because you need it in real time. You cannot store and forward. While with the DSN, in some instance we do that. In some instance we need to send in real time, but not necessarily real time. In a way, serial. Okay.
We got a question down in the front.
Hey. So obviously you're working with the data coming down from the TDRS network. In terms of your personal schedule and your work, how does this data come to you? Is there a particular schedule that you're operating on? I'm just curious about kind of how your workday breaks down into terms of when and how this data comes to you.
Well, what my group does is we ingest probably 10 or 12 gigabytes of data every day, day after day after day. And it's painful, or it's painless to us, because someone else has to actually go through making sure this happens, and then we just go to a secure website and have a very high capacity way of transferring the data onto our computers. But we have to deal with mass storage in hundreds of terabytes. And then one of the things with satellite data, when you use them, or with any data, is you have to have periodic reprocessings of the data, because you've discovered that you've made errors in your previous processing. And so you figure out what those errors are, you correct those, and you have to back up and then go through the entire archive again. But this is just part of the job. So to answer your question, it's painless to us, it's largely transparent, and there's someone else who's done all the hard work on the upstream end of the data which we use. So,
We've got one last question here.
Since I have an Earth environmental scientist in front of us, quickly linking a question about, in China they're just choking. And I have read about the China brown cloud and particulates in the air, which will, because of the particulates cut off some of the sun shining, you actually get cooling from that. Do you have any clarification of the issue of that?
Yes. If you're talking about aerosols in the atmosphere, which is what this brown cloud, or whatever color it is, cloud is composed of, if these aerosols are reflective, what you say is true. They will reflect the shortwave flux from the sun back into space and away from the Earth. On the other hand, if they have any amount of what's called black carbon, or very absorptive particles, then this will absorb the sunlight, and this will then warm the atmosphere. Now, one of the questions about aerosols is, what is the net effect? Is it this cooling effect, or is it this warming effect? There have been some recent papers just in the past several months which indicate that the warming effect from black carbon, or these darker particles, which are aerosols, is much more pronounced than people thought before. But one of the key areas in climate where people are actively working to work this out is, what is the effect of these aerosols? Is it a net cooling effect, or is it a net warming effect? And once again, it's only by having a combination of satellite data, so you know the spatial extent of these clouds and how they vary and where they are, in conjunction with ground-based data, that you can then determine what's going on, and then some intermediate data from airplanes where you fly through these clouds and actually collect them and then analyze what the particles are. So at the moment, the jury is out whether it's a net warming or net cooling effect, but it's being very actively studied at the moment.
Sure.
Yes, it's out, but it's not out for long, I think.
Wonderful. Thank you very much.
You're welcome.
So we're going to move on now to a slightly different, more overarching umbrella level and look at some of the policy and planning that happens for how we enable the future, how we carry out what we're currently working. And so here today from the Human Exploration and Operations of Space Mission Director at NASA headquarters is Greg Williams, and he's the Deputy Associate Administrator for Policy and Plans there.
Good morning. Hi, I'm glad to be here this morning. I was fascinated by the previous discussion for a couple of standpoints. One is I can see why we do the social media event here in Florida and not in Bolivia. Otherwise, you'd all be having Diet Cokes and aspirin on your tables. One of the things that was fascinating about Dr. Tucker's presentation, well, one of the many things, was this picture of the universe and the billions of galaxies, the billions of stars in each galaxy, and then you could almost round that out by saying, okay, now in addition to surveying all those, we're also staring with the Kepler satellite at one particular little region of our own galaxy and finding there already some 2,600 planet candidates. So wrap your mind around that. Just in one little piece of one corner of one galaxy are 2,600 planet candidates. Then you think about, well, how many planets are there to go along with all those stars and galaxies? Is really a fascinating thought. And again, it's the TDRS system and the scan systems generally that allow us to bring all of those data back to the Earth. There is a few set of slides that I'll show you here. We'll try to spend too much time on it because they're mostly boring words, but we'll just talk about what are the kind of things that we really want to do. Let's go ahead and have the first one. Again, talk a little bit about TDRS and its support to station and shuttle, and TDRS's future and our future in human spaceflight. Let's go to the next one. TDRS is how we talk to the International Space Station. The International Space Station has been permanently occupied in low Earth orbit for 12 years now. It's now in its full utilization phase, which means that station assembly is complete, and so now we're at the point where we can really get some mileage out of the use of space station. Oh, go ahead. The next one. In the future, again, the TDRS constellation you saw is aging. The last round of TDRS satellites were launched more than 10 years ago. TDRS-K is the first of a series of TDRS satellites that will replenish the fleet. TDRS-K this year, TDRS-L next year, and then we're planning beyond. And it's the TDRS fleet that's talking not only to space station, but also to SpaceX's Dragon Lab and other assets that are going to be flying to service the space station in the future. Let's have the next one. So speaking of the future, this is just one cartoon where we map out our future in human spaceflight. We're operating the space station. We're now engaged with a set of commercial partners who are going to be taking over the resupply of space station. We're already starting with cargo flights. SpaceX has had one so far. They'll have another one this spring. Orbital Sciences has their Antares vehicle on the pad at Wallops Island. We hope to have a demonstration flight of that in the spring, and then a first flight of it to the space station at the end of the year. And what that's going to do is it's going to free NASA up to leave Earth orbit and move beyond via the Space Launch System and Orion that Mr. Parsons talked about earlier. Where we want to go with those, again, is beyond the orbit of the Earth to the Moon, to the Earth-Moon Lagrange points, to near-Earth asteroids, and then eventually everybody's common destination in space is Mars. Let's have the next one. So this is how we talk about that. Mr. Parsons talked earlier about this capability-driven framework. This is what we mean by that. What we mean is that we're taking a stepwise approach into the solar system, starting with our initial exploration missions, of which space station is one. What we're doing on space station now is really going to enable our future in space in terms of learning how to work and operate in the space environment, then extending our reach beyond low Earth orbit to what we call cislunar space. Is that a familiar term to you, cislunar? Essentially, it means the volume of space around the moon. Because interestingly, it's the Lagrange points around the moon that are some of the most enticing locations for exploration beyond low Earth orbit. And then into the solar system, interplanetary space that we cover with scan with the Deep Space Network. and then eventually into low gravity bodies, near-Earth asteroids, and the moons of Mars, Phobos and Deimos, and then eventually to Mars and beyond itself. And so what we're doing is with SLS and Orion, we're building the capabilities that are going to allow us to go to a variety of destinations in space beyond Earth orbit. So the next one. Again, the International Space Station is where it all starts. It's critical to our future in space. It's the destination for the new series of commercial launch vehicles, and it's also what I have here described as an international collaboratory. And I sort of kludge those words together. What I mean by that is, yes, it's a laboratory in space. Yes, it's an international laboratory in space. But more than any of that, it is an international collaboration that is going to set the stage and the framework for the exploration we're going to do in the future. It's pretty much clear to all of us that our future in space beyond low Earth orbit is going to proceed internationally. No one country has the resources to do it alone. And when you think about it, our leaving the Earth really ought to be a whole planet endeavor. And it's the framework that we've established with our international partners in space station that is going to allow us to launch that international collaboration into the future. Let's go to the next one. Again, I mentioned the commercial cargo and crew transportation. You heard some more about that from Mr. Parsons this morning. We'll go on from there. Exploration systems development. Okay, so these are the capabilities that we're developing to succeed the space shuttle. The space shuttle had a 30-year run with and some amazing missions to deploy satellites and service the Hubble Space Telescope and build the space station, but it's really designed to operate to provide access for crew and cargo to low Earth orbit. If you want to go beyond low Earth orbit, back to the moon or onto Mars, you're going to need an architecture that looks vaguely familiar from the Apollo era. You're going to need a heavy lift launch vehicle, and you're going to need a crew vehicle that's capable of flight beyond low Earth orbit and re-entry through the Earth's atmosphere. And that's what the SLS program is going to provide, along with Orion and the ground systems here at the Cape. Let's have the next one. The Space Launch System, again, will be the largest and most powerful launch vehicle that has ever been flown. It's going to have an initial capability of 70 metric tons, evolvable to 105 and 130, which I'll show you more about secondly. But it has to be affordable and it has to be sustainable. This has to be something that we can do in the economic climate in which we're in. If we're going to have a space program that ventures beyond low Earth orbit in this current economic climate, it's going to have those features of affordability and sustainability. Let's go ahead to the next one. This is the evolution that Jeremy Parsons alluded to earlier, from an initial Block 1 capability of 70 metric tons and 320 feet tall, to a Block A, 1A capability with a larger payload fairing and 105 metric tons, which will allow us to do many of the cislunar things that we want to do. And then a Block 2, if we're going to go on to Mars, this is the kind of lift capability that we're going to need. We'll have to be able to fly a number of these to provide the kind of masses that would carry and sustain large robotic and then human expeditions to Mars. Let's go with the next one. This is the Orion multi-purpose crew vehicle. It has a crew capsule capable of supporting 3 or 4 astronauts, its own power system. One of the interesting things about this that's new in terms of our programmatic development internationally is that the service module for the initial versions of Orion is going to be provided now by the European Space Agency. That was an agreement that was recently completed, and we had a press conference down at Johnson Space Center a week or 2 ago to talk about that. Again, the most important thing about that is that it brings international partners into our future exploration programs. And that's something we're very excited about because, again, if we're going to explore to Mars, it's going to have to be in cooperation with other nations. Let's go on from there, please. I wanted to just return to this again because all of those capabilities we're building is fitting into a framework that is a stepwise progression from where we are now in low Earth orbit out to beyond the moon and on to Mars and even beyond that. Let's go have the next one. And just to conclude, none of this happens without TDRS satellites, right? When Badri and I and others were younger, there was only one phone company, and it was called Ma Bell, right? So Badri is, I think of as PA, Com, and Nav. Because nothing happens in space without the services that these folks are going to provide. And I hope you're going to be able to follow the launch tomorrow. We're really looking forward to it. The weather looks good, and I think we're good to go. I'm happy to take any questions you have with time remaining. Oh, thanks.
Do we have questions? Don't be shy, guys.
Yes, it's something you referenced earlier about the Lagrange points between the moon. I guess after post-ISS, are we looking to maybe put something in that spot as like a stationing point to go towards, Mars or into the moon or beyond?
Yeah, there are a variety of things that we're looking at. We've done some studies on visiting a Lagrange point with Orion and SLS, being able to take or provide the capability for either us or a commercial provider or an international provider to have a capability, an outpost at such a location. We've talked about doing some sample return activities. For example, if you wanted to do sample return from the South Polar Aitken Basin of the Moon, which is a scientific priority, that it's possible that you could telerobotically control those activities from an Orion visit or a internationally provided capability at L2. So it provides because it's a gravitationally stable point, it provides some real opportunities to be able to sustain a presence, but also to be able to transfer to and from other locations to that point. So we're looking at a variety of things. And I think those things will unfold over the next few years as we begin to see the first Orion and SLS launches, and there'll be some enthusiasm generated for what we can do at those locations. Yeah.
Last year I was at, or a few years ago I was at Glenn, and they were working on the Constellation program, which is, but they were working on the supply for the Orion. So, but you just said that that's going to be taken care of in the European market now. So that being the case, how is the research that was done at Glenn being transferred to them so that we don't have to repeat that kind of recreating the wheel?
Yeah, Glenn is very much involved in that partnership. Glenn will remain in the management of that activity. The Europeans will be working with Glenn and coming to Glenn to test and do the final design and not the manufacture, but the receiving of that and the testing of the capability. So Glenn's very much involved. And the arrangement with the Europeans as such is that they might provide one or two of those, and then subsequent ones would be manufactured potentially by a vendor here. But Glenn is going to be managing that whole process. Glenn, in addition, is going to be doing some testing, by contrast, for the Europeans. The Europeans want to do some upper stage work with their Ariane, and they want to come to Glenn because Glenn has the capabilities to do that testing work. So they're going to remain very active in this area. Yep. Yeah.
Yeah, with I don't know if you were following the recent refueling demo on the space station from, I think, last week, where they were able to robotically refuel and just kind of demonstrate that. Do you see that as a possibility to have something like orbital fuel depots in space to kind of extend the reach of crewed missions and all that stuff? Yeah,
definitely. There's a variety of applications for that kind of technology. One of which is our fuel depots in deep space. Another of which are the servicing of satellites in geostationary orbit. One of the things that the shop that created that technology is very interested in is whether they can extend the life of commercial or other assets in geostationary orbit by providing those kind of capabilities. But refueling depots in space are and servicing depots in space are something we're going to have to be able to get to. Refueling has a whole other set of problems with it because it's not just the manipulation of the satellite and the running of hoses and the connections to deconnections, but it's also the physics of the fluid transfer, which is something that our Space Technology Mission Directorate is also working on. They want to do some demos in that area, and then we'll be able to bring those technologies together and do some pretty interesting things. But that kind of robotic servicing in space is going to be critical to the future.
Does that include the backside of the moon as well? There's been talks in some of the space chat rooms about the backside of the moon and man-tiered station on the back of the zero gravity launch.
Yeah, the backside of the moon is intriguing for a lot of reasons. The fact that one could that it's easier to launch off a body with 1/6 gravity than one that's larger is intriguing. Although it's being able to actually, when you go around and tour the Cape and you see the launch facilities and the complexity that's required, it's not just a matter of gravity, it's a matter of having the infrastructure there, so that's interesting. There are also those who like the idea of using the backside of the moon as an astronomical observatory. To be able to find a smallish crater there, fill it with a layer of mercury, and create a super smooth mirror to do some observations. So the backside of the moon is an intriguing opportunity. Yeah.
And you just answered a little bit of what I was going to ask, but with the new capabilities of the new rockets, is it possible to build bigger space telescopes, and would it be useful to put them further away from Earth?
Yeah, there is. The James Webb Space Telescope is going to open up a lot of those possibilities. The James Webb Space Telescope is going to be at the Earth-Sun Lagrange point, L2, not the Earth-Moon Lagrange point, but the Earth-Sun Lagrange point, which is 1 million miles away. It's going to be a 6.5 meter telescope, in contrast to the 100-inch, 2 meter telescope that Hubble is. And it's going to be a fantastic capability. The fact that we're doing that opens up still larger possibilities. There are folks who have imagined 20-meter telescopes and so on, and the whole if you've watched the animation of how James Webb is going to be deployed, you can see that there's a lot of automation and robotics involved in how that telescope will be unfolded. When you get to something that's 20 meters, now you're talking about really complex deployment operations in space, and the ability to be able to robotically control, robotically deploy and assemble, and then eventually robotically service such a telescope is certainly something that is an active area of conversation. And there are a number of publications and animations that go with that. There's I'm trying to recall the name of the book, but there were a set of proposals that were called vision missions. And if you Google vision missions and Mark Allen, he was the editor of that book, you'll be able to see, get to that set of publications that was done in cooperation with the American Association for, AIAA, American Institute for Aeronautics and Astronautics, that will show you some of those concepts and what they might be for the future. But being able to assemble, deploy, and service those things robotically will be a key technology in the future, I think.
Do we have any more questions?
Okay, thank you very much.
Then. Thank you. So we wanted to let you guys know that the rocket is now out on the launch pad, and we are continuing on with getting ready for launching tomorrow evening. So that's extremely exciting. As a result of the rocket being rolled out this morning and so on, our next speaker is currently on his way here from the launch pad and from overseeing things out there. So we're going to instead hear next from the Deputy Project Manager for the TDRS-K mission. He works on all the business side of everything that happens there, and his name's Mr. Gifford Moak, and he's from Goddard Space Flight Center. So.
Thank you. So I've got some slides that I'm going to run through here, and if we can throw up the first slide. Okay, so the second slide, please. So what my boss is going to tell you is that we're getting ready to launch here on 8:48 on Wednesday night, and we're excited about that. There's a little bit of a picture of the constellation. Badre's already talked to that. Next slide, please. So one of the reasons we have TDRS is so that we don't have tracking sites all around the world. So early in the 70s, we had tracking sites all around the world. We had problems with political unrest potentially with that. Coverage wasn't total. I think Badre also touched on that point. Next slide. So what we had was planes, we had ships, as well as ground stations. Next slide, please. So, you know, what we ended up coming up with was a concept to put some satellites up to transfer this data back down to the Earth as a way to kind of collapse down that infrastructure and make it more stable. And again, I think this is following what Badre talked about. Next slide. So Badre talked a little bit about the zone of exclusion, which was an area where we couldn't get coverage. And so next slide, what we did was we ended up adding some ground sites, one of which was Guam, to close that zone of exclusion. So if you go out to White Sands, New Mexico, which is where we have our 2 ground sites, we actually have the White Sands ground terminal, which was the original ground site that was built, and then we built a second TDRS ground terminal, and so that's on up the road a ways. And the next slide shows you both of the ground facilities. You can see in the lower right the second TDRS ground terminal, and the first one up at the top is the original ground site. So the big dishes are what we're tracking the data coming down from the satellites with. Next slide, please. So this is a picture of the White Sands with the flags. It gets very windy out at White Sands, so that's a pretty picture. Next slide. So this is another picture of the dishes in the back that you can see. Next slide. I've got a lot of pictures. I'm not trying to get into a lot of the technical stuff. If you've got technical questions, my boss will be here. As they said, I do more of the business end of it. But the dishes are pretty large. You can see the entrance to the building down there. So next slide. So this is an aerial view of the second ground terminal. Next slide. So again, the dishes in the background. The far dish in the back, the two far dishes are for the Lunar Reconnaissance Observatory. So that LRO, and then the other one was Solar Dynamics Observatory, which is looking at the sun. And they're dedicated dishes that are sitting there. So they're part of that complex that we ended up putting those there. But they're not really part of the TDRS network. Next slide, please. So again, a picture of the mountains in the background. This is a pretty picture. Next slide. So we've got some antennas in Guam. Those are the next slide. We've got several pictures of Guam. That's another next slide. So you can see the panoramic view of Guam. Next slide. Next slide. So this is the control centers that we have. So you can see the number of operators there. They're there 24/7, monitoring the health of the spacecraft, monitoring the data that we're getting down, making sure that the data is properly been transmitted, and transmitting that data back through to the users. Next slide, please. Another shot of the control center. Next slide. So who do we support? I think, again, it's a little bit repetitious, but we're supporting basically 4 groups. We've got human spaceflight that we're supporting. We're supporting a lot of the Earth science missions, which Dr. Tucker talked about. We're supporting the space science missions, Hubble being the most famous of which. And we're supporting launch vehicles as they go into their early orbit. So we can track those. It used to be that they'd run out of range, and there was a time where we'd lose contact with them. But we're able to do that now. So a lot of the missions that go off, even though they don't provide continuous support through TDRS, we're tracking those as they get launched off the pad. Next slide, please. So this is the concept today. It shows a little bit of where the spacecraft are at the moment and where they're deployed. So they're basically at 3 points around the Earth. Next slide, please. So this was the original generation TDRS that we built. It's an interesting, if you got a business background or more into the business rather than the engineering side of it. I was a contracting officer at the time, so I helped administer the contract that wrote this. The spacecraft itself was built by TRW. It was under Space Communications Company, was our prime contract. And what's interesting about this is we didn't buy the spacecraft. What we actually bought was 10 years of telecommunications services. It was a very unusual contract, so what we did was we paid theoretically for service as we got it. It was, as I said, very interesting. It also meant that we were off-budget financed, which meant that it did not, when you went year to year, we did not get a budget from Congress. What we did was we borrowed money from the Federal Finance Bank. The company actually borrowed the money. We co-signed on the loan, if you will. And then as they actually got on orbit and as they started to provide us service, we started paying for that service, and we liquidated that. So it was a lease to purchase sort of arrangement. Next chart, please. So this is a launch on the Space Shuttle Atlantis for TDRS-E. So I think we've mentioned the first 7 spacecraft were launched aboard the shuttle. And since then, we've been launched on expendable rockets. Next slide, please. So this is the view of the TDRS-D inside the shuttle bay before it's released. Next slide, please. So what you see is the TDRS, and the back end of that is the upper stage that was boosting it, the initial upper stage. So next slide, please. And this is, you can actually see a full-scale model of this if you come up the Washington, D.C. area in the Air and Space Museum that's out at Dulles Airport. So it's hanging from the ceiling there. Next slide. So this is the second generation TDRSs. My boss started working on the first generation at the tail end of this, and he's been the project manager for a while, so he's he helped launch these HIJ. Next slide. So they were all launched aboard the Atlases. Those are the 3 Atlas launches that we did for HIJ. Next slide. So we're into the third generation now, so a little bit of differences from spacecraft to spacecraft. Jeff's here? Yes, indeed. I'll turn this over to Jeff. He's much better briefer than I am. We'll get her.
We're going to do something slightly different here. We've got a couple of different folks here, but this is Jeff Gramling. He's from the TDRS project, and he's going to finish briefing on here. And he can probably tell you what it looks like out on the pad and what we're going to be seeing later today. So,
thank you.
All right, well, hello and good morning, everyone. We just actually rolled the launch vehicle out to the pad. Pretty exciting, so we're in good shape for tomorrow. So thank you, Gifford, for filling in, and I'm sure he had lots of neat information for you. So what we're launching tomorrow is what we call a third generation, TDRS K, L, and we're building M. So L will launch about a year from now, and M will be ready to launch in December of 2015. The main differences between TDRS K and the HIJ spacecraft that preceded it were of course, lots of technological differences. While it may look quite a bit similar from the pictures you just saw about HIJ, much of the inside, the electronics, had obsolescence issues, had to be replaced. All of the payload electronics had to be redesigned, and the solar panels, if you saw a picture of the HIJ spacecraft, both of the outer solar panels in each wing would be populated. This is a more efficient technology. In terms of communication services, we've got the same communication services we had on HIJ. That's S, KU, and KA band on the single access antennas. The one difference we did made was we went back to the architecture that we had on the 1 through 7 spacecraft, where we formed the beams for the single, or the S band, the multiple access return signals. So it's kind of hard to see here, but this is our S-band phased array on the nadir face. All right, we can go to the next chart. And this is just a blow-up, and you can see what's inside. The most obvious things are the 2 fuel tanks and the 2 oxidizer tanks there. You can see in the middle there. Next chart, please. And some nice pictures. This was TDRS K in the factory. The one on the left is on the vibration table. The little the basket you see under it is to catch the things that we hope aren't there in terms of FOD and things. And then the picture on the right is actually the thermal vacuum chamber where we simulate the space environment. This chamber, we actually get raised up into it. This is in the Boeing factory in El Segundo, California. Next chart, please. And this is just a nice picture of one of the 15-foot single access antenna reflectors. And there's kind of a unique piece of GSE they call the diving board, and it takes people with some unique skill sets to work on that thing. Next chart, please. And another one. This is the spacecraft with the one boom deployed. We check deployments. There's actually a huge offloader here, so obviously we're in 1G environment. We've got to offload, and there's wires coming from each of these. This is ground equipment, and it supports the load of this boom. This structure here is a truss that's only used during launch, in the launch configuration, to carry the loads. And then once we deploy it on orbit, that's just floats along with the boom. It doesn't serve any purpose after that. Next chart, please. Just some more pictures of the spacecraft with the booms being offloaded. You can kind of get a sense of how big they are. Next chart. And there's on a rotating table there, that's with the single access reflectors in the stowed configuration, and that's what we have to do to them to fit them inside the launch vehicle fairing. There's some Kevlar straps that once we separate from the Centaur after launch, we'll cut those straps and then they'll take their natural shape. Next chart. Another neat picture. And this odd-looking thing that you see sticking out here is actually one of our Omni antennas that we communicate with white sands, and that's how we would command the spacecraft in the event of a contingency. Once we get on station, that actually rotates out of the way, so it's not in the field of view of the S-band phased array antenna on the nadir face. Next chart, please. And there's one. I imagine that's before we shipped it. We put it in the shipping container. You can see the reflectors are unfurled, but the solar wings are folded nicely on each side with the outer panel exposed. So that would be the shape we stay in during the 10-day transfer orbit to power the spacecraft. So there's one exposed wing on each side of the spacecraft that we get power during that period. Next chart. And this is right before we shipped the K spacecraft. This was TDRS K here on the right, and TDRS L, which, like I said, will be launching about a year from now, on the left, being offloaded and testing the deployments. Next chart. Just another view of the same event. It was pretty unique, actually, that we had both spacecraft in that particular part of the factory in those configurations, so they've got lots of pictures. Next chart. And this is the spacecraft. Obviously, it would be in the horizontal position with the reflectors furled in the shipping container. So this is what went on the C-17 that we flew from Los Angeles to the shuttle landing facility in, and then that container would go to Astrotech in Titusville, and they would lift the cover off and take the spacecraft out, and that's where we fueled it for launch. Next chart. A picture of the C-17, and you can see the shipping container coming out of the back end. Next chart, please. And this is, there's some pictures from the vehicle process. So you can see the first stage booster there after they had erected it, and that's out on Complex 41. If you saw a picture today, we just rolled out to the pad, so we've actually got the whole rocket out on the pad with the spacecraft and the fairing at the top. It's pretty nice. I think tonight it'll be illuminated, so you may be able to see it if you're in Titusville. Next chart. Another picture of the launch vehicle from the bottom looking up. Pretty impressive, actually. Next chart, please. And here you can see a nice picture of the Centaur which is the upper stage, being lifted, and it will be mated on top of the first stage booster. Next chart. And here's our spacecraft folded very nicely, and you can see it fits just about perfectly here with the antennas folded, so not a lot of extra space. And one of the things we have to worry about in this design is it looks pretty comfortable and happy in that configuration, but during launch we actually vibrate a lot, so we have to worry about dynamic clearances for when it's vibrating. Next chart, please. And here's a picture of the spacecraft in the fairing after it's been hoisted, and it's actually being mated to the Centaur there. Pretty nice picture. That's up in the vertical integration facility out at Complex 41. Next chart, please. And this is actually before that picture. This was actually Saturday night a week ago. They do it was about 2 in the morning. There's a big convoy that moves up from Titusville out to the pad, and the spacecraft is in there. Pretty nice picture, and you can kind of get a sense of how big it is by comparing it to the vehicles right next to it. Next chart. And this was just a chart. In this business, it's not like building cars. It really does come down to the people. And for this particular spacecraft that we're launching this week, at peak we've probably had more than 500 or 600 people working the program between the government and Boeing, and then also making ground modifications at White Sands. And it really is about the dedicated people that you have who build these things, because it's almost all, or it is all, built by hand. Next chart. And that's the end of our presentation. Hopefully you enjoyed the pictures. It really is a nice process, and there's a lot that goes on, and I think we were able to find some pretty nice pictures to show you today. So thank you.
We want to thank everybody for joining us today at the NASA Social. We are going to be finishing off our TV broadcast here at noon in about a minute or so, and then we'll continue doing questions up here with Mr. Gramling and so on. For everybody who's following us online at home, please make sure to tune in to the launch tomorrow. We'll be covering it on social media. It'll also be broadcast on NASA TV. We'll also be covering everything else the agency has going on and continue to, so please follow us on @NASA on Twitter, or the NASA Facebook page, or the NASA page on Google+. So we really do appreciate everybody for paying attention and tuning in today to learn a little bit about this incredibly important mission and how it integrates into everything that NASA does. So thank you all very much for joining us at the NASA Social.
Good day and welcome to Mission Control Houston, where a team of flight controllers is watching over the systems aboard the International Space Station in support of the Expedition 34 crew in orbit. Today, the crew is focusing on experiments that once again look at plumbing concepts for future spacecraft using surface tension to move fluids instead of gravity, and also working on an experiment on how liquids with magnetic suspended solids might be used as smart fluids for mechanical purposes. Tom Marshburn worked with the Capillary Flow Experiment 3. That work is starting new experiments on flows in weird containers that can passively separate fluid. The researchers at the Portland State University in Oregon intend to use the results to help guide development of new systems for spacecraft that make plumbing a lot more like Earth plumbing, where the effects of surface tension replace the role of gravity. Chris Hadfield worked with the colloid experiment that looks at how solids suspended in fluids, called Investigating the Structure of Paramagnetic Aggregates from Colloidal Emulsions 3. Researchers at the University of Delaware will obtain data on magnetorheological fluids, and those are fluids that change properties in response to magnetic fields that could be used to develop new brake systems in robotics, essentially making them smart liquids. Hadfield also had some time to work on inventory management to get ready for the next SpaceX Dragon cargo ship. Crew also is continuing work on servicing spacewalk suits with minimal or no interaction with mission control, part of a demonstration called the ISS as Testbed for Analog Research, or ISTAR, and they're working with extravehicular mobility unit cooling loops, primarily Tom Marshburn, subdividing the tasks beyond the normal blocks of time that would have been scheduled for that on a normal type of thing where mission control watched over their shoulders. Yesterday, the crew did a fluid loop scrub to clean the lines and began work and is continuing today on adding iodine to the cooling water to prevent buildups that could clog the lines. The idea of the whole thing is to develop procedures that are much more refined and would, in the future, allow crews to complete the work without a lot of interaction with mission control, which would be very important for long-duration missions to distant places like like asteroids or other planets such as Mars, where the communication delays start to become a problem. Kevin Ford collected hardware from the amine swing bed today in preparation for its periodic maintenance. Researchers are evaluating how well the experimental vacuum regenerated amine system can effectively remove excess carbon dioxide from the atmosphere, helping out the other carbon dioxide removal systems. Ford also has taken digital photos of the various payload racks on the station to document any configuration changes for the Payload Operations Center people at the Marshall Space Flight Center in Huntsville, Alabama, which coordinates all of the research on board the space station. And the Russians Novitsky, Tarelkin, and Romanenko also work with a variety of their experiments and some station maintenance tasks. Romanenko routed some communication cables to get ready for the arrival of the next European automatic transfer vehicle later this year. Tarelkin worked with a relaxation experiment that makes ultraviolet spectrometer observations of the reactions in the xenon plasma from firings of two plasma contactor units that are on the outside of the space station's truss. And Novitsky worked on some headset maintenance. Outside the space station, robotics flight controllers in Houston, backed up by their Canadian counterparts near Montreal, have been using Canadarm2 and the Dexter fine manipulator system to move some spare equipment replacement units around. The slow but deliberate work by the robotics officers resulted yesterday in the transfer of a failed main bus switching unit from its temporary stowage location on external stowage platform 2 outside the Quest airlock over to external logistics carrier 2, which is on the starboard truss. That failed device was replaced last summer during spacewalks by Expedition 33's Sonny Williams and Aki Hoshide. Today, the ground robotics experts are going to be transferring a cargo transport container from external logistics carrier 2 and installing it on Dexter's temporary equipment holder. And then Wednesday, they'll move a direct current switching unit from external stowage platform 2 over to external logistics carrier 2. And then Thursday, they'll be stowing the Dexter unit on the mobile base switching unit. Anyway, a very busy week of robotic operations guided by folks here on the ground, freeing the crew on orbit for all of the up-close and personal research that needs to be conducted aboard the space station.
Iran hat im Staatsfernsehen Bilder veröffentlicht, die beweisen sollen, dass das Land einen Affen in einer Rakete erfolgreich ins All geschossen hat. Das Tier sei später wohlbehalten zur Erde zurückgekehrt. Angeblich diente der Test der bemannten Raumfahrt. Ausgezeichneter Dschungel. Die 6. Staffel von Ich bin ein Star holt mich hier raus ist für den Grimme-Preis nominiert. Es ist die letzte Staffel, die noch von dem im Oktober verstorbenen Dirk Bach co-moderiert wurde. Ebenso im Rennen um einen der renommierten Preise ist Günther Jauch für eine seiner Quiz-Sendungen Wer wird Millionär? Die Grimme-Preise werden am 12. April verliehen. Spektakuläres Flugballett. Wissenschaftler und Vogelfreunde haben über dem Süden des Landes ein für Israel seltenes Phänomen beobachtet. Tausende Stare vereinigten sich über einem Feld zu einer schwarzen Wolke. Die Vögel bildeten 20 Minuten lang eine Wellenform nach der anderen. Wissenschaftler sagen, dass die Flugshow dazu dient, Feinde wie Falken abzuschrecken.
Im Tropensturm Oswald sind an der Ostküste Australiens mittlerweile 4 Menschen ums Leben gekommen. In nur 4 Tagen fielen 820 Liter Regen pro Quadratmeter. Das ist fast so viel wie sonst in einem ganzen Jahr. Der Sturm führt auch zu einem bizarren Naturschauspiel. Riesige Schaumberge türmen sich weiterhin an der Küste. Burkhard Wennemar mit den Bildern.
Nicht nur Menschen, auch viele Tiere leiden unter der Flut, wie diese Pferde und Rinder einer von den Wassermassen eingeschlossenen Farm. Tausende Häuser stehen unter Wasser, teilweise so hoch, dass Helikopter ihre Besitzer mit Seilwinden in Sicherheit bringen müssen. In der eingeschlossenen Stadt Bundaberg musste das Krankenhaus evakuiert werden. Die Patienten wurden nach Brisbane ausgeflogen. Der Sturm sorgte aber auch für ein skurriles Naturphänomen. Die starken Winde setzten die Eiweiße von Algen frei und schäumten sie dann wie ein Mixer zu einem riesigen Teppich auf. Besonders die Kinder stürzten sich mit Begeisterung in dieses Schaumbad der besonderen Art. Und der Schaum weht auch in die Städte hinein. In dem Badeort Maroochydore liegt der Schaum bis zu 3 Meter hoch. Zelte und Wohnwagen verschwinden in der weißen Masse. Glück hatten 2 Polizisten, die fast von diesem Auto umgefahren worden wären.
Sturzregen hat Sturm Oswald die Küsten von Queensland und New South Wales getroffen. Jetzt zieht er weiter Richtung Süden. Peter Kunz berichtet.
Der Pazifik als Schaumschläger. Das Katastrophenwetter in Australien hat seine skurrilen, spaßigen Momente. Die Sturmsaison hat das Meer aufgepeitscht und in eine große Badewanne verwandelt. Wenn's wild wird, haben wir diesen Schaum immer, aber so hoch war er noch nie. Die wild gewordene Natur, Mensch und Tier in Australien werden von einer Katastrophe nach der anderen heimgesucht. Vor 2 Wochen waren es im Süden des Kontinents noch die Buschfeuer, jetzt ist es im Osten das Wasser. Nicht endende Regenfälle nach einem tropischen Zyklon, Flüsse gingen über die Ufer, Land unter, Down Under. An manchen Stellen ist Rettung nur aus der Luft möglich. Wir haben einen Flutrekord. Niemals in der Geschichte ist hier so ein hoher Wasserstand gemessen worden. Seit Tagen werden Familien evakuiert. Vor allem der Bundesstaat Queensland erlebt im Januar und Februar immer Stürme und Regen. Sie werden aber offensichtlich von Jahr zu Jahr schlimmer. Die meisten australischen Wissenschaftler sind sich einig, dies sind die Folgen des Klimawandels. Alles überschwemmt, aber jetzt wird sogar das Trinkwasser knapp. Viele Aufbereitungsanlagen haben vor der braunen Brühe kapituliert.
Guten Abend, liebe Zuschauer. Unser Wetter wird noch extremer, das heißt, es wird milder und vor allen Dingen auch stürmischer. Die milde Luft hat Mitteleuropa morgen erreicht. Höhepunkt des milden Wetters 9 bis 17 Grad und das Tauwetter reicht bis nach Polen, zum Teil in den Westen Russlands und in die Ukraine. Bei uns verbunden mit sehr viel Regen. Es kann zu Überflutungen oder Überschwemmungen in den nächsten 24 Stunden kommen. Heute ein Blick auf die Alpen und Alpen-Südseite. Sie sehen hier Norditalien, die Po-Ebene, der Gardasee hier zum Beispiel. Dort hat es also Hochnebel gegeben und Nebel, Temperaturen 3, 4 Grad, nachts um 0 Grad. Alpen-Südseite und die Alpen selbst. Herrlich in der Sonne heute, Wintersport war ideal. Naja, ein bisschen mild ist es ja und das wird morgen ganz ähnlich so sein. Schauen wir uns noch mal an die Wetterlage. Milde Luft also von Westen mit dem Regen, der heute Nacht über Süddeutschland hinwegzieht und dann morgen Norddeutschland, später auch den Süden erreicht. Es kommt erst einmal weiterhin die milde Luft zu uns. Erst am Wochenende wird es wieder winterlicher. Ihnen noch einen schönen Abend und machen Sie es gut.
Auch wenn ihn die Holländer Prinz Pilsje nennen, das Image des trinkfreudigen Schürzenjägers hat Willem-Alexander längst nicht mehr. Der künftige König ist volksnah und beliebt und mit Maxima hat er eine Bilderbuchkönigin an seiner Seite. Das Volk ist begeistert. Sie sind jung und werden die Popularität der Monarchie vergrößern.
Ich liebe es, dass es ein sehr sportlicher König wird und er ist ein sehr sportlicher Mann.
Es ist schön, einen jungen König zu bekommen. Er ist einfach näher am Volk. Näher, als es seine Mutter Beatrix sein will. Beliebt, aber stets unterscheidend zwischen Mensch und Majestät. Die strenge Frau mit der Betonfrisur gilt nicht umsonst als Vorstandsvorsitzende der Niederlande. Mit Willem-Alexander, seiner Maxima, die auch offiziell Königin wird, und den 3 Töchtern kommt frischer Wind in den Palast.
König Willem IV. ist eher lässig, er nimmt das alles so einfach richtig locker, so wie der Holländer heutzutage auch ist.
Und dann ist da ja auch noch die schöne Maxima. Skandalnudel knurren die Holländer zunächst, als Willem-Alexander seine neue Liebe vorstellt. Tochter eines Funktionärs der argentinischen Militärdiktatur, Happy Hour Studentin in Bars. Doch nach der Hochzeit beginnt eine einzigartige Love Story zwischen den Holländern und ihrer Prinzessin. Sie tanzt Samba auf Staatsbesuchen, schwimmt für wohltätige Zwecke in Grachten und glänzt mit eskedreifer Mode. Plötzlich ist das, was die Königin auf dem Kopf trägt, ein alter Hut. 75% der Niederländer trauen ihm den Königsjob zu, nicht zuletzt dank ihrer maximalen Beliebtheit.
Der ägyptische Präsident Mursi hätte eigentlich andere Probleme, als ins ferne Deutschland zu reisen. Sein Land ist in Aufruhr. Doch er kam trotzdem nach Berlin, in der Hoffnung, wenigstens ein Problem lösen zu können. Unsere Tagesthemen. Blitzbesuch. Ägyptens Präsident Mursi braucht Hilfe. Gedenktag. Ausstellung erinnert an NS-Terror und Spielideen. Smartphones auf dem Weg ins Kinderzimmer. Wenn ein Staatspräsident fast 3000 Kilometer weit ins Ausland reist, obwohl ihm das eigene Land gerade um die Ohren fliegt, dann muss er dafür sehr wichtige Gründe haben. Mohamed Mursi kam heute nicht nach Berlin, um der Kanzlerin einen höflichen Antrittsbesuch abzustatten. Mursi braucht dringend Geld. Es geht um einen millionenschweren Schuldenerlass und um Entwicklungshilfe, die die Deutschen nur zahlen wollen, wenn Mursi ihnen glaubhaft versichert, dass Ägypten nicht in eine neue, wenn diesmal auch religiöse Diktatur getrieben wird. Das hat er heute auch versichert, doch offenbar nicht glaubhaft genug, wie Matthias Deiß aus Berlin berichtet.
Er wird sie einfach nicht los, die Demonstranten. Auch in Berlin Proteste gegen Mohamed Mursi, Menschenrechtler, Ägypter, Christen. Die Kritik ist dieselbe wie auf den Straßen von Kairo. Mursi sei Diktator statt Demokrat und führe sein Land zurück in eigentlich vergangene Zeiten.
Ich möchte mehr Freiheit für die Menschen, mehr Kommunikation mit der Opposition, mehr Zusammenarbeit.
Europa macht einen riesengroßen Fehler von Unterstützen solcher Personen in seiner Partei.
Wir sind gegen ihn.
Es sind stürmische Zeiten für Mohamed Mursi. Er kam trotzdem und gerade deshalb. Merkel und Mursi, sie will ihn kennenlernen, er braucht Hilfe, vor allem Geld. Denn zu Hause demonstrieren sie auch, weil die Wirtschaft am Boden liegt. Und so war Mursi heute erkennbar bemüht, Bedenken zu zerstreuen. Ägypten wird ein ziviler Rechtsstaat sein, keine Militärdiktatur und auch kein Gottesstaat. Überzeugt? Die Kanzlerin scheint weiter Zweifel zu haben und gab Mursi viele politische Hausaufgaben mit auf den Rückweg.
Das eine ist, dass der Gesprächsfaden mit allen politischen Kräften in Ägypten auch immer vorhanden ist, dass die verschiedenen politischen Kräfte ihren Beitrag leisten können, dass die Menschenrechte in Ägypten eingehalten werden und dass natürlich vor allen Dingen auch die Religionsfreiheit gelebt werden kann.
Richtig zueinander finden schwer für die Freundin Israels und den Mann der Moslembruderschaft, der vor 3 Jahren noch Juden als Nachfahren von Schweinen und Affen bezeichnete. Er respektiere die Juden, sagte Mursi heute, bleibe aber bei seiner Kritik an Israel. Wenn Blut vergossen wird und unschuldige Zivilisten angegriffen werden, handelt es sich um ein Verhalten, das ich verurteile. Mursi, ein schwieriger, aber wichtiger Partner, mit dem man weiter reden müsse, meint der Außenminister am Ende des Besuchs.
Wir spüren alle, dass der künftige Weg Ägyptens noch nicht feststeht. Und wenn wir Einfluss in die richtige Richtung ausüben wollen, dann ist es ganz wichtig, dass wir den Dialog, das Gespräch suchen.
Zum Schluss kritische Fragen bei einer Podiumsdiskussion. Seht her, ich stelle mich und antworte. Als echter Demokrat wollte er sich heute präsentieren, der Mann, auf den zu Hause die blutigen Demonstrationen warten.
Und die Menschen in Ägypten demonstrieren, weil sie genau das bezweifeln, was Präsident Mursi heute in Berlin vollmundig versprach. Ägypten werde nicht zu einer religiösen Diktatur. Doch Mohammed Mursi hat seinen Muslimbrüdern bereits alle wichtigen Türen geöffnet, die zum Staatsapparat genauso wie die zur Justiz. Die Proteste gegen diese Unterwanderung lähmen das Land. Die Wirtschaft ist längst eingebrochen. Einst forderten die Ägypter in der Revolution vor 2 Jahren Brot, Freiheit, Gerechtigkeit. Jetzt geht es vielen nur noch um eines: endlich genug zum Leben zu haben. Karin Feltes berichtet.
Ali Ramadan in seiner Werkstatt. Ersatzteile von ausgeschlachteten Autos stapeln sich hier. Ali Ramadan kauft sie in Europa und verkauft sie in Kairo. Eigentlich, denn seit der Revolution läuft das Geschäft schlecht. Wo bleibt denn die versprochene Sicherheit? Wo bleibt die Regierung? Es gibt keine Arbeit, keine Produktion. Wir wollen ja produzieren, aber es gibt einfach nichts zu tun. Ein paar Straßen weiter rund um den Tahrirplatz. Kämpfe, Tränengas, Bilder, wie man sie leider kennt aus Kairo. Seit dem Sturz Mubaraks vor 2 Jahren gibt es immer wieder Unruhen. Das Land ist nicht stabil. Die Investoren bleiben weg. Nach Übergriffen auf Hotels hat das Auswärtige Amt die Reisewarnungen für Ägypten erneut verschärft. Das trifft die wichtigste Einnahmequelle des Landes, den Tourismus. Kutschfahrer Khaled Said geht es genauso wie Ali Ramadan. Keine Kundschaft, kein Einkommen. Es kommen zwar russische, chinesische und koreanische Touristen, aber die sind sparsam, wollen kein Geld ausgeben und mieten eben keine Kutschen. 10% des Bruttoinlandsproduktes hat der Tourismus ausgemacht, vor der Revolution. Seitdem ist die Branche um ein Drittel eingebrochen. Die einzig stabile Einnahmequelle im Land ist der Suezkanal. Internationale Handelsschiffe zahlen für die Durchfahrt in Devisen. Die braucht Ägypten dringender denn je. Das ägyptische Pfund ist seit einigen Wochen im freien Fall. Der Internationale Währungsfonds hat Ägypten zwar Hilfe versprochen, aber nur, wenn das Land seine Subventionen senkt, zum Beispiel für Brot und Gas. Und das in einem Land, in dem ohnehin ein Viertel der Menschen unter dem Existenzminimum lebt. Sollte es wirklich so weit kommen und die Preise tatsächlich steigen, würden er und seine Kollegen auf die Straße gehen, sagt Ali Ramadan. Zuerst sagten wir, damit alles besser wird, müssen Mubarak und das alte System weg. Gut, dann soll eben Mursi kommen. Wir hier haben Mursi gewählt, weil wir glaubten, Mursi sei besser als Hosni Mubarak. Aber wir haben uns geirrt. Also neue Unruhen. Womöglich eine sogenannte Brotrevolte? Auf jeden Fall ein Teufelskreis. Denn dann würde die Wirtschaft noch weiter einbrechen. Und Ali Ramadan kann noch lange auf neue Kunden warten.
Damit dieses Land nicht vollends abstürzt, muss sich der Präsident bewegen. Doch bewegt er sich wirklich in Richtung Demokratie, wie er es heute in Berlin versprochen hat? Ein Kommentar von Andreas Zichowitz vom Norddeutschen Rundfunk.
Traditionell haben Deutschland und Ägypten gute Beziehungen zueinander, jedenfalls zu Zeiten Mubaraks. Vielleicht hoffte Präsident Mursi daher auf eine Dividende schlechten Gewissens. Da hatte er sich geschnitten und mit Recht. Wer eben noch versucht hat, die Verfassung zu seinen Gunsten auszuhebeln und sich über die Justiz zu stellen, der klingt wenig glaubwürdig, wenn er verspricht, Ägypten werde ein Rechtsstaat sein. Am Nil geht es darum, die zahlenmäßig weit unterlegenen säkularen und liberalen Kräfte bei der Überwindung der Mubarak-Jahre einzubinden. Ohne ehrliche Angebote des Präsidenten an die Opposition, aber kein Dialog. Ohne Dialog kein Ende der Gewalt. Und die bringt das Land, wie eben gezeigt, wirtschaftlich schon jetzt an den Abgrund. Die große Mehrheit der über 80 Millionen Ägypter will Ruhe und Arbeit. Doch Mursi hat das Land innerhalb weniger Monate mehr gespalten als geeint. Er ist eben doch nur der Vertreter einer jahrzehntelang durchaus brutal unterdrückten Vereinigung der Moslembrüder, die nun endlich ihre Klientel versorgen will. Vielleicht ist er auch noch mehr. Der Vorbote und Vertreter einer breiten Islamisierung, die derzeit den Nahen Osten erfasst, mit Ägypten als Drehscheibe. Es war daher richtig, dass die Kanzlerin Religionsfreiheit und demokratische Reformen anmahnte und keine Blankoschecks ausstellte. Mit ihnen hätte sich die Moslembruderschaft vor den anstehenden Wahlen sicher gerne geschmückt. Ägyptens westliche Freunde müssen wachsam bleiben, solange Mursi bei uns Sphinx spielt und zu Hause den Pharao gibt.
Andreas Zichowitz kommentierte. Der 30. Januar 1933 war der Tag, der das Leben von Inge Deutsch-Krohn veränderte. Bis dahin hatte das Mädchen mit ihren Eltern Weihnachten und Ostern gefeiert. Doch nun, da die Nazis in Deutschland an die Macht gekommen waren, erfuhr das damals 10-jährige Mädchen, dass sie Jüdin war. Schon bald musste sie sich verstecken in dunklen Kellern und großer Angst. Inge Deutsch-Krohn ist inzwischen 90 Jahre alt und hat heute im Bundestag mit bewegenden Worten über den Tag, an dem Adolf Hitler Reichskanzler wurde, gesprochen.
Dicht an dicht, so standen sie am Straßenrand in jener Nacht des 30. Januar 1933. Männer und Frauen, Junge und Alte. Und sie grüßten die vielen Hunderte, die in ihren khakifarbenen Uniformen mit dröhnendem Marschtritt durch das Brandenburger Tor in die Stadt einmarschierten. Brennende Fackeln in ihren Händen.
Weil sie im Untergrund überlebte, hat sich Inge Deutsch-Krohn zur Aufgabe gemacht, immer wieder über diese unheilvolle Zeit zu sprechen und auch als Autorin darüber zu schreiben. Und sie sagt dabei sehr deutlich, dass die meisten Deutschen die Nazis nicht nur aus Angst oder Gleichgültigkeit, sondern mit Jubel und Begeisterung unterstützt haben, genau wie es auch eine neue Ausstellung im Berliner Dokumentationszentrum Topographie des Terrors zeigt. Esther Neumeier berichtet.
Berlin heute Mittag. Trotz des Regens ziehen Kauflustige vorbei am Schuhhaus Leiser. Vor 80 Jahren standen hier Schaulustige. Erschütternd gleichgültig beobachten sie, wie die Nationalsozialisten zum Boykott des jüdischen Geschäftes aufriefen. Es sind Fotos wie diese, die den Blick schärfen. Den Blick auf Deutschland vor 80 Jahren. Ein Land, das innerhalb weniger Monate marschierte in die Diktatur. Ein Deutschland, in dem schon 1933 Gewalt und Unterdrückung zur Tagesordnung gehören. Was war damals geschehen? Die Ausstellung versucht aufzuzeigen, wie sich das NS-System allmählich etablieren konnte.
Das Ziel der Ausstellung ist, Menschen klarzumachen, was passiert, wenn Polizei und Regierung nicht durch unabhängige Gerichte kontrolliert werden. Dann kommt man zu einer Erosion der bürgerlichen Rechte und das ist das Ende der Demokratie.
Mit den bekannten verheerenden Folgen für ganz Europa. Am 30. Januar 1933 ernannte Reichspräsident von Hindenburg Hitler zum Reichskanzler. Einen Monat später brannte der Reichstag. Danach wurde rücksichtslos durchgegriffen, wie es diese NS-Zeitung ankündigt. Andersdenkende werden verfolgt, inhaftiert, ermordet, das Parlament entmachtet, die Justiz gleichgeschaltet. Diese Menschen waren mutig, sie versuchten, das Erstarken der NSDAP zu verhindern. Doch es gab nur wenige von ihnen. Den Reichstagsabgeordneten Johannes Stelling zum Beispiel. Wahre Helden, die die Ausstellung aus dem Vergessen holt. In den ersten Monaten der Nazidiktatur bezahlten Hunderte ihren Mut mit dem Leben. Zivilcourage und Engagement statt Politikverdrossenheit, das sei auch heute das beste Mittel gegen Rechtsextremismus, so die Kanzlerin bei der Eröffnung der Ausstellung.
Wir können es nicht anders sagen. Der Aufstieg des Nationalsozialismus wurde möglich, weil die Eliten und Teile der deutschen Gesellschaft daran mitwirkten, vor allem aber, weil die allermeisten in Deutschland diesen Aufstieg zumindest duldeten.
Das Wissen gerade über die Anfänge der NS-Diktatur weiterzugeben, sei wichtig, um Gefahren von rechts erkennen und vorbeugen zu können. Auch deshalb wird derzeit an historischen Stellen in Berlin erinnert, an 1933. An die Tage der Machtübergabe und den radikalen Bruch mit der Demokratie.
Die meisten Verantwortlichen der Nazi-Verbrechen sind inzwischen verstorben. Selbst die zentrale Stelle zur Aufklärung nationalsozialistischer Verbrechen glaubt nicht mehr daran, dass noch Täter vor Gericht gebracht werden können. Doch einer ist anderer Meinung. Dem Rechtsanwalt Thomas Walter ist es bereits zu verdanken, dass sich der ehemalige Wachmann aus dem KZ Sobibor, dem Janjuk, vor Gericht verantworten musste. Und alle gingen davon aus, dass es wohl der letzte große Prozess gegen einen NS-Kriegsverbrecher sein würde. Doch Thomas Walter gab nicht auf. Jetzt will er einen weiteren KZ-Wächter zur Rechenschaft ziehen. Doch die Mühlen der Behörden mahlen auch in diesem Fall langsam, berichtet Christian Stücken.
Thomas Walter ist sich sicher.
Dieses Dokument müsste den amerikanischen Staatsbürger Johann B. als Kriegsverbrecher überführen, als Wachmann des 7. SS-Totenkopf-Sturmbands, Einsatzort Auschwitz II, direkt an der Rampe und den Gaskammern.
Das war die harte Truppe, die wirklich auf der Rampe den Job machen musste.
Allen Erkenntnissen nach steht Johann B. im Sommer 1944 als Wachmann an der Rampe in Birkenau, als mehr als 400.000 ungarische Juden nach Auschwitz deportiert werden.
Und in diesem Tag, wenn wir dort waren, vergaß meine 10-jährige Schwester und meine Mutter.
Späte Gerechtigkeit. Das hat Thomas Walter sich zur Aufgabe gemacht. Früher war er Richter, jetzt vertritt er als Anwalt die Überlebenden. Kostenlos. Die Schuldigen sollen nicht davonkommen, auch wenn sie nur Wachmänner waren.
Das ist eine strafrechtliche Schuld der Beihilfe zum Mord, der dann planmäßig durchgeführt wurde.
Doch seitdem die Staatsanwaltschaft Weiden in der Oberpfalz für die Anklageerhebung zuständig ist, ist nicht viel passiert. Stattdessen fordert sie umfangreiche Gutachten zu den Vorgängen in Auschwitz an. Und sie fasst den Beschluss, Überlebende und Nebenkläger von der Polizei als Zeugen vernehmen zu lassen. Alarmiert fliegt Thomas Walter nach Budapest. Immer wieder hat er darauf hingewiesen, dass die dort lebenden Nebenkläger nichts zu Johann B. sagen können. Vergeblich. Als er seine Mandantin Blanka Pudler besuchen will, hat die ungarische Polizei sich bereits angekündigt.
Sie war sehr, sehr aufgeregt und richtig von Panik und Ängsten gezeichnet. Sie wollte auch mit mir überhaupt nicht mehr reden und keinen Kontakt haben. Sie wollte mit all diesen Dingen jetzt nichts mehr zu tun haben.
Vor einem halben Jahr hat Blanka Pudler das Bundesverdienstkreuz verliehen bekommen. Für ihre Bemühungen um Aussöhnung. Die psychische Belastung einer Vernehmung ist zu viel für sie. Die Staatsanwaltschaft Weiden möchte zu dem Fall kein Interview geben. Schriftlich heißt es zur Vernehmung der Überlebenden: Ihnen soll Gelegenheit gegeben werden, im Ermittlungsverfahren zu Wort zu kommen. Das sind wir Opfern und deren Angehörigen schuldig. Für Thomas Walter ist das reiner Zynismus. Er macht sich inzwischen Sorgen, ob nach der angekündigten Zeugenvernehmung vielleicht noch mehr Nebenkläger aufgeben. Besuch bei Erzsébet Schemes. Sie möchte unbedingt, dass es zum Prozess kommt.
Ich will alles wissen, was ist geschehen hier in Auschwitz.
Sie ist bereit, sich vernehmen zu lassen. Der Wachmann soll keine ruhige Nacht mehr haben und verurteilt werden. Das sei sie ihrer Familie schuldig.
Es ist so, dass Menschen wie Frau Schemes mir auch signalisieren, mach es weiter und sorge dafür, gemeinsam mit einer funktionierenden Justiz in Deutschland, ohne das geht es nicht, dass diese Prozesse zu Ende geführt werden.
Die Zeit drängt. Und so tut Thomas Walter alles, damit die Schuldigen noch vor Gericht gestellt werden.
Wegen der Pannenserie beim Flughafen Berlin-Brandenburg hat der Bund der Flughafengesellschaft gedroht, den Geldhahn zuzudrehen. Die Nachrichten mit Susanne Daubner.
Der Haushaltsausschuss des Bundestages beschloss, erst dann weitere Mittel bereitzustellen, wenn ein Konzept und ein Kostenplan vorliegen. Der neue Aufsichtsratsvorsitzende des BER Brandenburgs, Ministerpräsident Platzek, sagte, es gebe noch keinen neuen Eröffnungstermin. Auch die Kosten ließen sich nicht seriös abschätzen. Im Moment stehe nicht einmal fest, ob der Flughafen groß genug geplant sei.
Auf einer Konferenz in Kuwait ging es heute um dringend benötigte Hilfen für syrische Flüchtlinge. Nochmal Susanne Daubner.
Die Opfer des syrischen Bürgerkrieges sollen mit mehr als 1,1 Milliarden Euro unterstützt werden. Das haben die Vertreter von 59 Staaten auf einer Geberkonferenz in Kuwait beschlossen. Nach Schätzungen der Vereinten Nationen sind etwa 4,7 Millionen Menschen auf Hilfe angewiesen.
Satari, das größte Auffanglager für syrische Flüchtlinge. Zehntausende leben hier auf dem jordanischen Wüstenboden an der Grenze zu Syrien. Sie harren aus, sind angewiesen auf Hilfen der Vereinten Nationen. Die Hälfte von ihnen Kinder und Jugendliche. Es gibt Zehntausende Flüchtlinge auf der anderen Seite der Grenze. Die wollen hierher, aber das Camp ist zu klein. Dazu kommt, dass wir den kältesten Winter seit Jahren haben. Viele der Kinder schlafen in der Feuchtigkeit und Kälte. 59 Länder kamen heute in Kuwait zusammen zur Geberkonferenz für Syrien. Dort sammelte UN-Generalsekretär Ban Ki-moon die erhoffte Summe von etwas mehr als 1,1 Milliarden Euro. Vor allem dank der Zusagen aus arabischen Ländern. Mehr als 1 Million Syrer sind innerhalb des Landes auf der Flucht vor der Gewalt. Sie verlassen die umkämpften Gebiete wie Aleppo. Bislang haben mehr als 700.000 syrische Staatsbürger ihr Land verlassen.
Die israelische Luftwaffe hat angeblich ein militärisches Forschungszentrum in Syrien angegriffen. Bei dem Bombardement in der Nähe von Damaskus sollen 2 Gebäude zerstört und 2 Arbeiter getötet worden sein. Das sagte ein Sprecher des syrischen Militärs im Staatsfernsehen. Das israelische Militär wollte die Berichte nicht kommentieren. Zuvor hatte es Spekulationen gegeben, wonach Israel einen Lkw-Konvoi angegriffen habe. Dieser soll mit Waffen für die radikal-islamische Hisbollah bestückt gewesen sein. Die Zahl der Toten durch die schweren Überschwemmungen im Nordosten Australiens ist auf mindestens 6 gestiegen. Inzwischen sinken die Pegelstände einiger Flüsse wieder. Vereinzelte Regionen sind jedoch weiterhin von der Außenwelt abgeschnitten. Tausende Häuser stehen unter Wasser. Ausgelöst wurden die Überflutungen durch die Ausläufer eines tropischen Wirbelsturms.
Die Smogwolke im Norden Chinas dehnt sich aus. Wie das chinesische Umweltministerium erklärte, bedeckt sie inzwischen eine Fläche von 1,3 Millionen Quadratkilometern, fast 13% des Landes. In Peking raten die Behörden, zu Hause zu bleiben. Die US-Botschaft warnte vor, so wörtlich, gefährlicher Luft. Verursacht wird der Smog vor allem durch den hohen Kohleverbrauch in China und den zunehmenden Verkehr.
In Peking nutzen die Menschen ihre Handys momentan vor allem dazu, den aktuellen Smogwert abzurufen. Denn wegen des gefährlichen Feinstaubs in der Luft sollen die Menschen in der Millionenstadt am besten nur noch zu Hause bleiben. Schon 4-mal in diesem Winter sind die Werte dramatisch angestiegen. Mittlerweile überzieht der Smog eine Fläche, die 4-mal so groß ist wie Deutschland. Ja, wird das denn so dramatisch bleiben, Sven Plöger, oder dürfen die Pekinger hoffen, dass sich die dicke Luft bald mal wieder verzieht?
Ja, Karen, in der Tat dürfen die Pekinger wirklich jetzt hoffen, dass sich was tut, dass sich was verbessert. Das war ja eine wirklich zähe Geschichte. 4-mal in diesem Jahr. Wir hatten ein langes, zähes Hochdruckgebiet, praktisch keine Luftbewegung. Und dann reichert sich eben tatsächlich in der Luft dieser ganze Staub an. Wir gucken uns mal einen Strömungsfilm an. Zunächst mal ist es nur ein Standbild. Sie sehen hier praktisch keine Pfeile rund um Peking. Windstille hier, die Berge drumherum, die Peking natürlich auch immer schützen. Jetzt lassen wir diesen Strömungsfilm laufen. Hier oben die Uhrzeit, dortige Zeit. Und Sie sehen, hier kommen Windböen auf. Insbesondere in der Nacht zum Freitag und am Freitag chinesischer Zeit. Die sind 7 Stunden vor uns und da wird sich dann einiges tun. Da werden sich die Verhältnisse verbessern.
Hearing into gun control, let's have a listen.
Simply 2 reasonable Americans who have said enough. On January 8th of 2011, a young man walked up to Gabby at her constituent event in Tucson, leveled his gun and shot her through the head. He then turned down the line and continued firing. In 15 seconds, he emptied his magazine. It contained 33 bullets, and there were 33 wounds. As the shooter attempted to reload, he fumbled. A woman grabbed the next magazine, and others restrained him. Gabby was the first victim. Christina Taylor Green, 9 years old, born on 9/11 of 2001, was shot with the 13th bullet or after, and others followed. The killer in the Tucson shooting suffered from severe mental illness, but even after being deemed unqualified for service in the Army and expulsion from Pima Community College, he was never reported to mental health authorities. On November 30th of 2010, he walked into a sporting goods store, passed a background check, and walked out with a semi-automatic handgun. He had never been legally adjudicated as mentally ill, and even if he had, Arizona at the time had over 121,000 records of disqualifying mental illness that it had not submitted into the system. Looking back, we can't say with certainty, only if we had done this, this would have never happened. There isn't just one thing that would have prevented the Tucson shooting from being written into the history books. Gabby is one of roughly 100,000 victims of gun violence in America each and every year. Behind every victim lays a matrix of failure and inadequacy in our families, in our communities, in our values, in our society's approach to poverty, violence, and mental illness, and yes, also in our politics and in our gun laws. One of our messages is simple. The breadth and complexity of gun violence is great, but it is not an excuse for inaction. There's another side to our story. Gabby is a gun owner, and I'm a gun owner. We have our firearms for the same reasons that millions of Americans just like us have guns, to defend ourselves, to defend our families, for hunting, and for target shooting. We believe wholly and completely in the Second Amendment and that it confers upon all Americans the right to own a firearm for protection, collection, and recreation. We take that right very seriously, and we would never ever give it up, just like Gabby would never relinquish her gun, and I would never relinquish mine. But rights demand responsibility, and this right does not extend to terrorists, it does not extend to criminals, and it does not extend to the mentally ill. When dangerous people get guns, we are all vulnerable. At the movies, at church, conducting our everyday business, meeting with a government official, and time after time after time, at school, on our campuses, and in our children's classrooms. When dangerous people get dangerous guns, we are all the more vulnerable. Dangerous people with weapons specifically designed to inflict maximum lethality upon others have turned every single corner of our society into places of carnage and gross human loss. Our rights are paramount, but our responsibilities are serious. And as a nation, we are not taking responsibility for the gun rights that our founding fathers have conferred upon us. Now, we have some ideas on how we can take responsibility. First, fix gun background checks. The holes in our laws make a mockery of the background check system. Congress should close the private sales loophole and get dangerous people entered into that system. Second, remove the limitations on collecting data and conducting scientific research on gun violence. Enact a tough federal gun trafficking statute. This is really important. And finally, let's have a careful and civil conversation about the lethality of firearms we permit to be legally bought and sold in this country. Gabby and I are pro-gun ownership. We are also anti-gun violence. And we believe that in this debate, Congress should look not towards special interest and ideology, which push us apart, but towards compromise, which brings us together. We believe whether you call yourself pro-gun or anti-gun violence, or both, that you can work together to pass laws that save lives.
Thank you.
Thank you.
Thank you.
It's an honor to be here today on behalf of the more than 4.5 million moms and dads, sons and daughters in every state across our nation who make up the National Rifle Association of America. There are 4.5 million active members of the NRA, and they're joined by tens of millions of supporters throughout the country. It's on behalf of those millions of decent, hard-working, law-abiding citizens that I'm here today to give voice to their concerns. The title of today's hearings is, What Should America Do About Gun Violence? We believe the answer to that question is to be honest about what works and honest about what doesn't work. Teaching safe and responsible gun ownership works, and the NRA has a long and proud history of doing exactly that. Our Eddie Eagle child safety program has taught 25 million young children that if they see a gun, they should do 4 things. Stop, don't touch it, leave the area, and call an adult. As a result of this and other private sector programs, fatal firearms accidents are at the lowest level in 100 years. The NRA has over 80,000 certified instructors who teach our military personnel, law enforcement officers, and hundreds of thousands of other American men and women how to safely use firearms. We do more and spend more than anyone else on teaching safe and responsible gun ownership. We join the nation in sorrow over the tragedy that occurred in Newtown, Connecticut. There is nothing more precious than our children, and we have no more sacred duty than to protect our children and to keep them safe. That's why we asked former Congressman and Undersecretary of Homeland Security Asa Hutchinson to bring in every available expert to develop a model school shield program, one that can be individually tailored to make our schools as safe as possible. It's time to throw an immediate blanket of security around our children. About a third of our schools right now have armed security already because it works, and that number is growing every day. Right now, state officials, local authorities, and school districts in 50 states are considering their own plans to protect children in schools. In addition, we need to enforce the thousands of gun laws already on the books. Prosecuting criminals who misuse firearms works. Unfortunately, we've seen a dramatic collapse in federal gun prosecutions in recent years. Overall, in 2011, federal firearms prosecutions per capita were down 35% from their peak in the previous administration. That means violent felons, violent gang members, and drug dealers with guns, and the mentally ill who possess firearms are not being prosecuted. And that is completely and totally unacceptable. And out of more than 76,000 firearms purchases supposedly denied by the federal instant check system, only 62 were referred for prosecution, and only 44 were actually prosecuted. Proposing more gun laws while failing to enforce the thousands we already have, it's not a serious solution for reducing crime. I think we can also agree that our mental health system is broken. We need to look at the full range of mental health issues, from early detection to treatment, to civil commitment laws, to privacy laws, that needlessly prevent mental health records from being included in the National Instant Check System. While we're ready to participate in a meaningful effort to solve these pressing problems, we must respectively, but honestly and firmly disagree with some members of the committee and many in the media and all the gun control groups on what will keep our kids and keep our streets safe. Law-abiding gun owners will not accept blame for the acts of violent or deranged criminals, nor do we believe that government should dictate what we can lawfully own and use to protect our families. As I said earlier, we need to be honest about what works and what does not work. Proposals that would only serve to burden the law-abiding have failed in the past, and they'll fail again in the future. Semi-automatic firearm technology has been around for 100 years. They're the most popular guns for hunting, target shooting, self-defense. Despite this fact, Congress banned the manufacture and sale of hundreds of semi-automatic firearms and magazines from 1994 to 2004. And independent studies, including one from the Clinton Justice Department, proved that it had no impact on lowering crime. And when it comes to background checks, let's be honest. Background checks will never be universal because criminals will never submit to them. There are a lot of things that can be done, and we ask you to join with us. The NRA is made up of millions of Americans who support what works. The immediate protection for all, not just some of our school children, is what's needed, and swift, certain punishment of criminals who misuse guns and fixing our mental health system. We love our families, we love our country, we believe in freedom, and we're the millions from all walks of life who take responsibility for our safety and protection as a God-given fundamental American right. Thank you, Mr. Chairman.
Thank you. Now, that was Wayne LaPierre, the Executive Vice President and CEO of the NRA, the National Rifle Association, seen as an extremely powerful lobby group in Washington, said to represent 4.5 million members, but also the gun industry, according to its critics. Now, earlier we heard from former Congresswoman Gabrielle Giffords, wounded in a mass shooting 2 years ago. She gave an emotional opening statement. Here's just a piece of it.
Violence is a big problem. Too many children are dying. Too many children. We must do something. It will be hard, but the time is now. You must act. Be bold, be courageous. Americans are counting on you. Thank you.
Let's start in Washington, D.C. As she continues to recover from being shot in the head, former Congresswoman Gabrielle Giffords urges U.S. lawmakers to support tighter gun control. In America, there's been a high-profile intervention in the debate over President Obama's gun control proposals. Former Congresswoman Gabrielle Giffords was shot and seriously wounded 2 years ago. Today, she gave evidence at a Senate committee hearing on gun-related violence.
Thank you for inviting me here today. This is an important conversation for our children, for our communities, for Democrats and Republicans. Speaking is difficult, but I need to say something important. Violence is a big problem. Too many children are dying. Too many children. We must do something. It will be hard, but the time is now. You must act. Be bold, be courageous. Americans are counting on you. Thank you.
Well, the BBC's Paul Adams is in Washington, D.C. He's been listening to Gabrielle Giffords' testimony.
Whenever Gabrielle Giffords speaks at all, the entire country sits up and takes notice. And I don't think she has uttered any more significant words in the last 2 years than the short statement she gave to the Senate Judiciary Committee just a short time ago. As you can tell, it's very difficult for her even to speak. She was shot in the head while meeting constituents in Tucson, Arizona, just 2 years ago. It's very, very difficult. Her recovery has been amazing. And so her intervention right at the beginning, she was invited to speak before the senators spoke themselves, most unusual break with tradition, got the proceedings off to a pretty electrifying start.
That's BBC's Paul Adams. Now
잠시 뒤 발사하겠습니다.
Finally, after 3 attempts, South Korea has become a spacefaring nation. Spectators watched nervously as the Naru rocket, built with Russian help, blasted into orbit. Officials confirm its small satellite was successfully deployed in space.
The rocket was successfully launched at 4 p.m. The satellite was separated 540 seconds after the launch, and after analysis, the satellite had successfully entered the orbit.
South Korea's past experience with rockets has been patchy. Its first launch in 2009 reached orbit, then failed to detach. The second, a year later, exploded just 2 minutes into its flight. This was a much-needed proof of South Korean ability. Especially since this. North Korea launching its own satellite on a domestically produced rocket last month. The achievement was criticised by the United Nations, but heralded in Pyongyang as a technological victory over the richer, more advanced South. But the space program here in South Korea has been focused on satellites, not rockets. For years, its main military ally, the United States, restricted long-range rocket research, fearing it may accelerate a regional arms race. But now, that situation is changing fast. In recent days, Japan has launched spy satellites to monitor the region. China and the US say they've tested missile interceptors. South Korea has now joined that elite space club.
In China,
Japan, in the Koreas and elsewhere, there's a strong sense of pride and national pride and a strong sense of scientific nationalism. So when they see other countries pursuing these projects and they see success, they feel a need to follow or to match those achievements. So right now it's a very competitive atmosphere.
And South Korea has now proved itself a competitor, and that the space race in this region is far from run. Matthew Chance, CNN Seoul.
It's to be third time lucky for South Korea's space program after it launched a satellite to collect data about the weather patterns. The rocket was shown live on television as it blasted off from the country's south coast. After two previous failed launches, South Korea's space engineers are under pressure because North Korea put a satellite into space last December.
This is what we're looking at. This is the radar for this part of the world. Here's Atlanta right there. So this is where CNN Center is located. We have been tracking severe weather across the southeastern U.S. all day. There were already several tornadoes, at least one confirmed. That one was in Tennessee near Nashville. This is the line of storms that has been producing this nasty weather. The latest tornado would be this one right over here. You can see it kind of moving through here across this northern portion of Georgia. That one reportedly has left people trapped in their homes. It has left a lot of damage along the highway, overturned vehicles. This is going to be a serious situation that continues to develop here across the southeast. If you happen to be traveling to the busiest airport in the world, which would be the Atlanta Hartsfield-Jackson International Airport right there, you could probably be looking at some travel delays as this line of storms moves through a little bit later today through this area. So nasty weather is the leading edge of a clashing mass of air that is very warm to one side and very, very cold Arctic air behind it. So that continues to be one of our top stories today. Back to you.
Seit dem Untergang der Titanic vor 100 Jahren weiß man ja, wie gefährlich Eisberge oder Eisschollen für die Schifffahrt sind. Das ist ja bis heute so. Weshalb man sich in die richtig arktischen Gewässer eben auch nur mit sehr speziellen Schiffen wagen kann. Die Polarstern ist ein solches Kraftpaket, ein echter Brecher. Durch 1,5 Meter dickes Eis fährt sie kühl lächelnd einfach hindurch. Noch dickere Schichten rammt sie weg. Derzeit ist das deutsche Forschungsschiff auf einer 18-monatigen Expedition im Südpolarmeer, um dort die Folgen des Klimawandels zu untersuchen. Unsere Wissenschaftsredakteurin Hildegard Wert ist mit an Bord. Und wenn man sie fragt, wo genau bist du jetzt eigentlich, da wo es die Eisbären gibt, antwortet sie, nein, ich bin nicht in der Arktis, wo es die Eisbären gibt, sondern in der Antarktis. Das ist da, wo es die Pinguine gibt. Pinguine, Wale, Robben, aber vor allem sehr viel Eis.
Mitternacht auf der Brücke der Polarstern. Und plötzlich ist es da, das erste Treibeisfeld unserer Expedition. Viel früher als erwartet. Eis, soweit das Auge reicht. Es ist offenbar altes Treibeis, das sich seit mehreren Jahren zusammengeschoben und verkeilt hat. Ungewöhnlich für diese Jahreszeit und diese Meeresregion. Aber was ist schon normal in diesem Jahr, das bisher das kälteste in der Geschichte der umliegenden Inseln war?
Zumindest nach den Eiskarten hat es noch keinen Witterungsumschwung, sprich starke Westwinde gegeben, sodass wir damit rechnen müssen, dass wir auch wieder unter Schwierigkeiten und natürlich auch mit entsprechendem Zeitaufwand dieses Forschungsareal an der Ostseite der antarktischen Halbinsel erreichen können.
1 Stunde braucht die Polarstern, um sich durch den Eisgürtel zu boxen. Dann liegt wieder freies Fahrwasser vor uns. OFOS wird in die Tiefe geschickt. Ein Kamerasystem, das den Meeresgrund erkundet. Wir befinden uns am Rand des Kontinentalsockels. Das Meer ist hier rund 200 Meter tief. Dort unten herrscht Finsternis. Das Kameralicht tastet Seespinnen, Seegurken und Seesterne ab. Sie können über 1 Meter groß werden. Für die Walforscher ist das Wetter perfekt. Sie zählen die großen Meeressäuger aus der Luft per Helikopter. Und sie müssen nicht lange warten. Schon vom ersten Tag an tummeln sich zahlreiche Wale rund um unser Schiff. Die Polarstern arbeitet sich etappenweise vor Richtung Südosten. Alle paar hundert Seemeilen macht das Schiff Station. Es bleibt nicht stehen, sondern es kreuzt systematisch auf einer Fläche von mehreren Quadratkilometern. Dann geht es rund an Bord. Mehr als 40 Forscher aus 5 europäischen Ländern und den USA wuseln über das Arbeitsdeck, bringen Netze und Messsonden aus.
Wir haben fast alle Geräte, die wir auf der Expedition gebrauchen werden, erstmalig eingesetzt. Es gab gute Ergebnisse. Manche Geräte hatten noch kleinere technische Probleme, aber sie haben alle gut funktioniert.
Viele hier an Bord forschen seit Jahren in der Antarktis. Nun wollen sie in eine der unzugänglichsten Regionen vordringen, ins Larsenschelfeis im Weddellmeer. Hier hat der Klimawandel in den vergangenen Jahren riesige Eistafeln abbrechen lassen. Hier bilden sich neue Lebensgemeinschaften. Aber auf dem Weg dorthin sind noch viele Eisbarrieren zu überwinden.